Hey, hey, hey. Where is that coming from? Let's go find out while we have time, right? Yeah, right? Hey, 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 hey. There's like a delay between my voice and then that. Hey, hey, hey. And I gotta check if that's coming out. Hey. Yeah, there's like a. You hear that delay. It's like slower than when I'm actually speaking. Nope. Hey. 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 It's coming out this. So this right here. I don't know how. I don't know why. But it's coming out right here. So my theory. No, you're good. So I took out my mains, and I think this is the echo. No, you're good, man. At least we figure it out now, right? So this would be my mix too. Let me test that right now. Right? Me too, actually. I'm like, that's pretty often, to be honest. Yeah. Like, this could be a little fill. So that's why I might be having some of the, you know, early. Well, let me just test it out real quick. If I stop my mix two line. So there's any way to. Whoo! I knew it. So it sounds like it because there's a latency delay between. Yeah. Yeah. Hey, hey. Yeah. 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 Well, so let me. Hey. Yeah, it's such a weird effect. Because there's that little delay. Almost sounds like reverb. Appreciate it, Nate. Yeah, it sounds good. I'm gonna clear all the mics and stuff, so yep. Yeah, I wanna get off this mic now. But sorry. Hey. Hey. Yeah, that's just room now. Button on the thing, right? Oh my god. Yeah, now I'm just getting me and whatever speaker Hey, hey. And hopefully we get nobody who does this. Like yesterday, a man spoke with the mic far away. Hey, hey. Let's see how loud I can crank this since we have. Hey, hey. Quiet people. Hey, hey, hey. That's pretty loud still. Okay, cool. Hey, hey, hey. Oh, I love it. We're getting even louder now. Hey, 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 hey. Why do I keep logging in? My computer. It doesn't log in. Hey. Hey. Yeah. Hey. Hey, hey. I wish I had separate receivers for the over the ear and this wireless mic because of the gain. The receiver's back there, and then, you know, it needs to be back there. Yeah, this is just so much better. Yeah. Hey, hey. Oh, yeah. There we go. Now I'm talking with my chest. But I have a pretty projection-y voice, but... Hey, hey. Actually, would you please? I'm about to head up there, too, and get rid of all the mics.
recessed and they get old. All right. By the way, I like the one of the presenters, the kid yesterday. From you can tell he's from Northern California. He was practically Indian style on the stage, but it was a lot of energy. I liked it. I'm sorry, say again. Oh man, yes, yeah. It's so much more intelligibility, even from from where my vantage point is. Hey, 1, 2, 3, and this is kind of a compromise as far as proximity of where the mic is. I'm not eating it, and it's not at my belt. All right.
Hey.
Boundary mic.
Yeah.
Participate.
Hey.
Software
Hey.
controller where you can just turn them on and off, but yeah, it's got such a really fantastic gate on it.
Yeah.
Where, man, it picks up pretty
Yeah.
well for the webcast too, because that's so popular these days. So they have to be.
Hey, hey. So that should just be in your mix. So you got that right there? Sound good? All right, cool. Hey, hey, hey. All right.
Can you just turn? Okay, that's good. That's good. Sit here and just hang out with her. Hello? Hello? All right. Good morning, everyone. Thank you very much for coming to our presentation this morning. I hope you guys are enjoying this conference. Today, we're going to spend the next 30 minutes talking about a very important topic for many companies, and that is my data ready for AI? And if my data is not ready, what are we going to do about it? And before we get into the discussion, I would like to first of all introduce myself a little bit. My name is Aaron Chang. I'm the Vice President of Data Science from Dot Data. Dot Data is a technology company based out of Northern California, San Francisco Bay Area. We are a pioneer in the field of feature engineering. And feature engineering is a key component in making your data ready for AI. One good thing about my job is that I got to work with our customers directly and applying our technology on solving their real problems and delivering business benefit. And with that, I'm deeply honored today to be joined by Pradeep. He's a global analytics director from Kennametal. Kennametal is a prestigious world leader in tooling solutions. And Kennametal has been a customer with us for the past 18 months. And today, Pradeep is going to share with you his perspective, his experience of using Dot Data and how his team is able to turn their data into more valuable assets and building AI solutions with our technology. So, so there's three key topics in today's presentation. The first one is I'm going to explain to you why the enterprise data is complex. And with that, you will understand why your data, you have a lot of data, but your data is not ready for AI. Then I'm going to conceptually introduce to you how Dot Data is solving this problem. And then Pradeep is going to share his personal experience of using Dot Data, what kind of success he's been able to achieve with our technology. And given the time limitation, I'm not going to be able to do a product demo here on stage right now, but 11:30 downstairs, Ian McKenna, he's the Director for Field Engineering from our company. He's going to do a live demo. If you guys are interested further in our product, please make sure you guys can join that demo so you will understand how this product is going to work. And I would like to start this discussion by drawing an I would like to start this discussion by drawing an analogy. And that is, we know that enterprises nowadays, they have invested a lot of money in generating, accumulating, and even acquiring data, because data is valuable. There's no doubt about that. However, data in its very rawest format is just like a crude oil. We know that the crude oil is very valuable. It's precious. People fight for it. But you cannot use a crude oil in that form to drive a vehicle. You cannot pump crude oil in an airplane. Crude oil needs to go through a very complex refinery process before it can become gasoline, which can be pumped into your car, which can be used to drive an airplane. And data is very similar. Data in its very raw format, it's valuable, but it's messy, inconsistent, too granular, massive. It's not ready for any AI applications. And data needs to go through a very similar refinery process before it can be ready for AI. And so this is what I'm going to tell you about. What is this data refinery process looking like? And this data refinery process, in a technical term, is what we call feature engineering. Now, the very natural question is, what is this feature engineering process looking like? If you look at the real-world data science project, it typically starts with defining a business problem, translating the business problem into a data science problem. After that, you need to acquire data. You need to do data sourcing. You need to do the ETL type of work. ETL is what we usually refer to, at this step, at this stage of the data, this stage of the pipeline, sourcing the data, doing the data transformation, doing master data management. However, as we all know that ETL most of the time is not intended for machine learning or for artificial intelligence purposes. That's why you need to do extra work, which is feature engineering, to make sure that data coming from your data warehouse can be fed into any machine learning models. Once your data becomes ready for machine learning, you can build models, then you can further deploy those models into production. That's what we call ML ops. If you look at this entire pipeline, recently there is a lot of advancement in terms of the ETL space, as well as the machine learning and ML ops space. However, there is nearly not as many tools or advancement in the field, in the feature engineering space. And that's why for many data science practitioners, we understand and we feel this pain that feature engineering has really become a bottleneck. Without enough of feature engineering capability, we cannot get our data ready for ML. And I'm going to explain this maybe in the context of a real world example. So this is a project I have been personally associated with. I remember 5 years ago, this bank customer, they came to us. They've been in the business for 30 years. They offer a variety of different consumer banking, credit card, mortgage services to their customers. In each one of those business areas, they have acquired a lot of data that is currently sitting in their enterprise data warehouse. And when they came to us, their interest is, with this data, can we develop some kind of AI solution which can help them understand a credit card product that they are very interested in promoting? Is this a good product? Are people happy with it? For people who are currently using it, are they going to turn away from it? And in their anticipation, once they have this kind of AI application built in the simplest form, they can have this kind of business dashboard being generated. Every day being refreshed, showing the list of risky customers, and for the customers that have a risk of churning, what is the reason that they are churning? And they hope that they can give this information to their sales and the marketing team, so those people can react to it, offering some kind of incentive or discount or some kind of promotion for those people to keep using those their credit card products. So this is a very, very typical data science problem. And I'm sure most of us here have some experience with customer churn problems. This is a very typical data science problem. The business context may be different for the churn problem you have worked with in the past. The data set can be different as well. However, there's one thing I'm very certain about, and that is that the data you are working with typically start with a situation like this. There's many tables. Each table has got many rows, many columns. The tables amongst themselves, there's very complex relationships. And some of those tables are very large, some of them are very small. Some of them are complex, some of them are simple. Some of them are transactional, some of them are static. And we also know that no matter what kind of a machine learning technology, AI technology you are using, data in this form is not ready for machine learning. Machine learning can only take a single flat table with clearly identified X columns, which we call predictors, and Y column, which we'll call the prediction target. Machine learning algorithm needs to take data in that format in order to work. However, as we can see, we are presented with so many tables. Now, how are we going to be able to condense those many tables in formulating the single flat XY table? And this is feature engineering. And in this case, as you can see, it's actually not very easy. It's way more complex than SQL joining. So this is why in a real-world data science project, feature engineering is complex. Right. With this, I'm going to introduce to you how our company is trying to solve this problem. Before I get to that, I want to briefly mention about .data. We are a venture-supported technology company based out of San Francisco Bay Area. We've got a global customer footprint, 55 customers plus. Our customers range from healthcare, to financial services, to even manufacturing industry. That's why today we have our customer, from manufacturing space to share his experience with us. Over the years, we have received a lot of recognition, not only from the leading market research companies like Forrester, but also from technology giants like AWS and Microsoft. And the core competency of our company is that we have developed this automated feature discovery engine, which will help our customers to turn their data ready for AI. With our technology, instead of spending many months preparing your data manually for AI, you can spend as short as just 1 day to get your data ready for AI applications. That can really help you jumpstart your AI journey. And the essence of our technology is that we have employed this data-centric approach to programmatically and statistically discover features from your data. Right? And with that, we can not only eliminate this manual process in doing data cleansing, doing data preparation, but also reduce the amount of human bias in doing that data scrubbing. And in this entire process, we enable the users to develop reusable feature assets so that the next time when you're analyzing the same data, when you're solving a similar problem, you do not have to go through this wasteful process of rediscovering features again. And this entire pipeline can be deployed onto a variety of different architectures. It can be even sitting on top of your current machine learning and AI application pipelines, which will help you deliver that business value a lot faster. And conceptually, how it works is that this thing is pretty sticky. Okay. Conceptually, how it works is that Jesus Christ. So this is how conceptually it's going to work. And that is that with this engine, essentially we can be connected to the source data, wherever your data might be. It can be an enterprise data warehouse. It can be a data lake, right? And then after the data connection is established, the user needs to provide a few inputs. Essentially, it's what data set are you interested in exploring? What prediction problem are you interested in solving? Then with that, our technology will automatically discover the relevant feature space that are useful for this particular prediction problem, right? And this is where we do that data combination, data aggregation, data cleansing, all the work that otherwise you would have to do manually, right? Now after that, .data will automatically recommend the list of features that are relevant for your interest. Then with that, what you can do is you can take the feature as is from .data. You can discard the features that you do not like. You can also customize the features according to your domain knowledge. At the end of this process, you have created this data that is ready for AI. So with this technology, we have prepared two different kind of interfaces for our customers. One is a programming interface. Essentially, it becomes a Python library. It can be deployed into the customer's workflow. Or we have also developed this graphic user interface. And with that, essentially, it's a drag and drop type of application. Right? This is really depends on the customer's preference. And this is how it's going to work in your current ecosystem. Right? This entire pipeline can be deployed seamlessly with a variety of different upstream and downstream applications. I'm not going to be able to get to the details of this page, but if you guys are interested in this architecture aspect of our product, please make sure to stop by our booth, and I'm very happy to provide more information. I really want to give this opportunity to Pradeep so that he can share his experience of using this. So with that, Pradeep, please.
Thank you so much, Aaron. How many of you had heard about Kennametal before today? That's awesome. Whether you flew here or drove your car, most likely components that went into these modes of transport were made with tools that we make. So Kennametal is a world leader in tooling and wear resistant solutions. We were started in a town called Latrobe, Pennsylvania, just about 1 hour away from Pittsburgh. So we've been in business for more than 85 years, and we serve customers in over 100 countries, at least 80,000 plus customers, 8,700 employees, and we help provide solutions for various industries like aerospace, as I mentioned, energy, and so on. Oops. Kennametal has had a rich history of using data to help with decision making for several years. We had several decades of experience with business intelligence sort of technologies, but building predictive analytics models and AI, we've had point solutions built for us by vendors, but homegrown solutions that was new to us. In fact, our manufacturing teams took the first step to invest in a couple of data scientist resources. And one key learning we got from that experience was pairing these data scientists with the business domain experts. The business domain experts likely have hypotheses, and they were able to help identify that these could be potential data sources, and our use cases in the manufacturing space were predictive maintenance to help detect when some key assets may go down in an unplanned way. However, after several months of iteration and working with different data sources, the team came to the conclusion that they were not collecting the right types of tags from our machines, from sort of IoT sort of data. So they were basically back to the drawing board. So a key learning from this experience for us as a company, and as with many other areas, if you're going to fail, fail fast. And that was a key learning for us. And when we were setting up a new data science shared service to serve all other areas, not just manufacturing, my desire was, we don't know how long it's going to take for us to execute and deliver a meaningful solution. So we started small. We said the first year with our new data scientists, if we can deliver one good solution, we aimed for quality, not quantity. If we can deliver one, that was success, we said. And around the same time is when we heard from the .data team about how they have helped accelerate building features, key features, and especially when the domain experts may or may not have the time, .data's feature factory product with Databricks, as well as the enterprise product, which we ended up licensing for our needs. We found that that was a good start for us to help with our journey. And when we started, one of the key constraints was our domain experts were able to identify key areas where we may be able to build predictive models, but they may not have known the right data sets, or they may not have had the time to work with our data scientists to help build the models. So there were different data sources. In some use cases, we of course use ERP, SAP ERP for our needs, and we had CRM sort of data, homegrown applications, and so on. And there were several use cases we had worked with our business to identify, prioritize, but with the help of .data, we started with a low goal of 1, but we were able to far exceed that, at least 3 use cases that we were able to put into production and able to execute at a speed that we did not anticipate. So the key there is the feature discovery and model building, and we didn't know if we had the right kind of data. That's no longer our constraint. With the help of .data, it's not just about the successes, referring to the fail fast idea earlier. We've had cases where we've tested and we realized within 2 weeks that we don't have the necessary data. Maybe we need to capture a snapshot of data every month before we try this maybe in 1 year. I would rather do that earlier on rather than waste 6 months and then discover that. So that's one key area. And of course, our domain experts, there was a use case from our finance team. They wanted us to build a forecasting model. They had a more naive forecasting method in place, but they didn't have a lot of time to work with us. But just defining the problem statement and helping my data scientists set up the problem the right way with .data and with solution expertise from the .data team, we were able to deliver a solution within 3 weeks. Our forecasting model was way better than what they had in place. And with far less involvement from the domain expertise from the finance team, all they had to do is define the problem, give us some pointers, and then 3 weeks later, they were just validating the model. So I don't know if that would have been possible with our earlier solutions. Putting it all together, Aaron also referred to customer churn being a problem that is common in more industries. We are a business-to-business company. We sell both direct and indirect. And in our case, as we strengthened our digital sales channels, our digital team wanted to understand what is our customer churn, what causes customer churn. They had some hypotheses about maybe certain types of complaints being filed could be predictive of a customer likely to leave us in the next 6 months to 1 year. And we had data from our ERP system, transactional data. We had Dynamics data, CRM is what we use for our complaints. And we also had activity data of what's going on with our sales teams contacting these customers. And then we had some homegrown systems as well. So putting all these together in a traditional way, I don't have a baseline because we didn't try it with other methods. It may have taken us months based on our experience with other areas. But within 3 hours, by connecting the tables more in a star schema sort of a format with what you would have seen with business intelligence tools. But by point-and-click sort of solutions with the .data Enterprise product, we were able to go from thousands of features into being able to identify the key variables. And we also found something unique. We had a hypothesis that customers who file complaints may be predictive of churning, but counterintuitively, .data helped us identify that in our industry, for whatever reason, customers who file a lot of complaints were not likely to churn. So these sort of things which the domain expertise does not really help, it has helped us uncover. And there were other features. The explainability of these features is also key. Being able to get those in a format where we can explain to our business teams that maybe there was one example there, wrong part number ordered. One of the forms on our website which allowed people to enter which product and what quantity, that was not very intuitive. That was leading to customers entering the part number in the wrong field. So these sort of simple interventions, which it's not just the machine learning model building, it's also the pointers to say what process areas could be improved. That was also key with the feature engineering piece. With that, I think that was the last slide we had. Yeah, that should be it. Thank you.
Thank you very much. If you guys have any further questions, make sure to join the demo 11:30 downstairs or stop by our booth. Any questions you guys have, I'll be at the booth.
Hello, hello, hello. Good morning, everyone. I think we'll get started in about 4 minutes, so please settle down when you get a chance. All right. Good morning, everyone. My name is Amit Dingare. I'm the Director of Data Science at Novelis. And we are an aluminum manufacturing company. What you see on the screen right now is what we make. So it's good to see two presentations on manufacturing back to back. We are kind of like the unsung heroes. We don't get that much publicity. This is not considered like a typical application of AI. But I truly believe that for AI to make an impact on the human lives, it has to permeate into the manufacturing. And we have been playing our part in that. So I'm here to talk about what we have done and where we stand at this point. Okay. We are a B2B company, like I think the previous presenter. We make flat-rolled aluminum coils, and then we supply those aluminum coils to 4 segments: aerospace, CAN, car, automotive, and then a bunch of assorted one, which we call specialties. So we have many customers that you probably know. In the automotive sector, you pretty much have seen our cars being on the road. The latest Ford F-150 that came out has pretty big contribution of Novelis aluminum. And then CAN is one of our biggest segments in the world, actually. We are a global company with 15,000 employees. We have presence in 9 countries with 30+ aluminum plants. And the goal of the AI is to basically create value in manufacturing, right? So while the team has been working on various use cases in other areas, supply chain, procurement, finance, I'm going to focus on manufacturing for today, very specifically. So we started our journey in the world of AI about 5 years ago with the establishment of a digital center of excellence. And the goal of this digital center of excellence was to create value leveraging advanced analytics in manufacturing. And when I talk about advanced analytics, it includes basically data science, artificial intelligence, and operations research. So those are the areas where we focus right now. What we have done is we have hired data scientists from various other industries as well as from academia. So we have 20+ data scientists right now. And these are very highly trained people in their fields. And leveraging this team, my team basically creates value in manufacturing operations. So one of the things that has really worked for us is we actually get value targets every year for us to meet. So we kind of like work as like salespeople. We have to achieve certain value targets, and then we work with our plants to achieve those targets that we get. In addition to the value goal, we also have a goal of building capability. So every year we train people within our manufacturing operations. And we think that this combination of value creation and building capability is very essential, very paramount to permeating the value of AI within the company. So you have to do those things together for you to create value. Yeah, in terms of, I think, just the techniques, we focus on AI. And when I say AI, I'll talk about different components of AI in the next few slides. So in manufacturing, right, one thing that has happened as a part of Industry 3.0, if you haven't heard that term, I would encourage you to look it up because right now there is a lot of focus on Industry 4.0. And in the 3.0, basically, one thing that Novelis did really well is they went through a very high sensorization effort. So many of our machines are highly sensorized, and we capture a lot of IoT data from our machines. So we leverage the data from those sensors. We leverage image data. We have cameras in many plants at many places. We leverage that data. Of course, tabular data is ubiquitous. We use that. And then we have text data. So leveraging all those data sources, we basically focus on applying various techniques. So We start with conventional machine learning. This is where your random forest, XGBoost, gradient boosting, right? Unsupervised learning algorithms come in. We do deep learning for unstructured data. We use constraint optimization, which is more on the linear programming, nonlinear programming for supply chain problems a lot of times. And then we do simulation for building digital twins within Novellus. And in terms of our focus areas, there are 5 focus areas actually that we focus on, specifically in manufacturing. We focus on improving the cycle time, which is to make the whole process faster or do more in the same amount of time. We focus on improving the yield, which is to reduce the wastage that happens. We reduce on the machine downtime. Many of our machines are these gigantic machines. If you go to any rolling company, you will see these big mills that probably maybe as big as this building. And they are very critical for our operations. A downtime of 1 hour of downtime in some of these machines is quite expensive. So we focus on reducing the downtime. Cost is a very big component of our work, and more specifically on the energy side. After the current geopolitical situation, energy has become a very high focus for us, and we are a very high energy intensity business. So we try to focus on reducing our cost, primarily through energy, but also from raw material. So if we can make more from the recycled aluminum, that helps us with our business, and it's also good for the environment. And aluminum is one element that can be infinitely recycled. So that's one thing that we focus on, is how do we cut down usage of the prime aluminum, which is the raw aluminum, and use more recycled aluminum. And lastly, but the most important, is improving safety. Safety is our #1 focus within Novellus. So this is a very important slide. When we started our journey in AI, right, we had to figure out how we want to position this human-machine interface, right? And what I have on the left-hand side is a slide from Gartner. Gartner published this about 3-4 years ago. And they came across, or they came with 3 different arrangements how machines and humans can interact. And the first one is the decision support, right? Where the traditional BI type of work basically falls in, right? You have dashboards, you have visualizations that actually help humans to make decisions and make better decisions. And that's where humans play a much bigger role and machines play a smaller component. Then comes the decision augmentation, where the role of the machines actually becomes much larger compared to decision support. In that particular case, the machines basically make recommendations and humans largely act upon that, but within the guardrails of their senses. So if they don't find certain recommendations correct, they can override that. And then there is a decision automation, where machines play almost as an autonomous role. And this is where autonomous cars basically come in, where cars can drive themselves with a very less supervision from humans. And we, trying different options, what we have found is the decision augmentation is where you can get the best value. And the reason is, first, the change management with decision augmentation is much easier. You can actually get the humans, because humans are still in control, and they ultimately make decisions. In terms of putting your models or putting your algorithms in production, it becomes much easier. You also have human guardrails in place. So if a model basically has not seen that data and it makes incorrect predictions, well, you have a human supervision on top of that, and that can cut down the errors that you have. And finally, in many cases, what we have seen is when we apply this approach, the AI can actually act as a on-the-job coach for humans. In many cases, we have models built where the models became equalizer at the shop floor, where operator was making decision based on his or her intuition, experience, knowledge, and we learned that intuition through the models, and then these models now became equalizer for a new person to come in and apply those same recommendations. So that's where we focus at this point. And in this particular one, I've given a very high-level use cases that we have basically leveraging different focus areas and the improvements that we are seeing from those. So as I mentioned, we have the 5 areas on the top, which is from improving cycle time to improving safety that you saw on the earlier slide. And in the rows, I have the different types of techniques that we use in our AI shop right now. And of course, I'm not going to go through each of them in the interest of time. But to just focus on some of them, I think, as I mentioned, sensorization is a very important thing because once you do that, you can actually leverage that data for various use cases, right? We leverage the IoT, industrial IoT data for anything from machine health to finding the root causes of defects to making recommendations for the operators on the right parameters. And we have done several use cases on that where historically a human used to make decision based on their experience, and then we have trained the models to understand that intuition, and now these models are providing recommendations to operators for setups. Computer vision is an unsung hero actually nowadays. I mean, you are seeing a lot of publicity and talk about generative AI, but actually what we are seeing is computer vision has probably the bigger application in manufacturing and in many industries as well. We have been able to develop various use cases leveraging computer vision, right from safety, where now we have cameras that leverage and that leverage computer vision to give specific recommendations to our EHS teams to focus on areas that they wouldn't have done before. So historically, they would not have that amount of data where violations are happening. And now using computer vision, we are actually giving them very specific recommendation that this type of violation is happening in this area, so go and talk to the unit manager. In terms of generative AI, we are trying a few new things where we are building some bots that are trained on our maintenance data, that are trained on our safety data, and they're providing recommendations to the operators, very specific recommendations to the operators. If there is a problem, these bots can actually, people can ask questions to these bots, and then these bots can provide them answers. We also think that there is a big value in terms of generating the synthetic data, leveraging generative AI. Because in many manufacturing cases, you don't have as much defective data. So you need to figure out how to train your models, and if you can generate that data synthetically, you can actually solve a lot of use cases. This slide shows how we work. I think somebody mentioned this earlier, but in manufacturing, historically, the focus on data has not been there. In many cases, this is true with many manufacturers. The data is always siloed in different plants, have their own databases. And what we were thinking originally is to bring all that data into our data lake and then build use cases on top of that. But slowly we realized that the amount of effort required to do that is quite a bit. So what we started doing is we started going at the source itself and generating the MVPs there. So MVPs, minimal viable products. And once we see the value, then we work with our data engineering team to bring that data into data lake, and then we productionize use cases. And this flipping the sequence of data engineering and data science has helped us quite a bit in showing the value quickly, because in many manufacturing use cases, if you don't show the value quickly, people lose interest. And that has been the biggest learning that we had. We have recently launched a program called Plant the Future, where we are actually applying digital in various areas, right from improving safety, energy, efficiency, and uptime. And that's helping us. I'm actually wearing a vest of Plant of the Future. This is a multi-year program that we are running at Novels. And we have pretty large ambitions in terms of how digital can penetrate into manufacturing. So, as I said, I've been in this job for 5 years. I built this team grounds up. I have a few lessons that I learned that I want to share with all of you. First of all, you need to have a long-term approach when you're building something, a team like this. It's a marathon, it's not a 100-meter race. So think about that all the time. Change management is very, very important. In the early part of my career, I did not really understand the importance of that. But as I learned my lessons, I would say that for you to do, basically deploy any use cases in manufacturing, you have to focus on change management. And to do that, you have to find some champions of that in different plants, in different areas first. And when you do that, you find a good way to basically manage the change. I talked about the third one already, where you have to flip the data science workflow, focus on generating the value quickly, and then thinking about productionizing it. The fourth portion, or the third one, sorry, I have two-thirds, so that's the wrong one. The snowball effect, right? So when you start something, you start small, and as you start small and show the value, it generates into a big value driver for you. So I would recommend focusing on that. Capability building must be in place. If you just do AI without having focus on training people to use AI and generate value, that effort won't go anywhere. So you have to do those things together, create value at the same time, focus on enabling AI in the organization. And finally, I would say the center of excellence model is a good way to permeate the capability before you assign that capability to different functions or different plants. So we have learned that quite a bit, and it has been a good journey for us so far. So thank you for your time, and happy to take any questions if you have time. Yeah, so the question is what software tools we use. To a large extent, we are an open source shop. We have certain products like Databricks that we use for our manufacturing use cases, but we prefer leveraging open source in many cases. Yeah, that actually is a very good example of why decision augmentation is a model that works for us, right? We always have a human supervision on top of the models, right? We don't let, at this point, what we have found is the best way to deploy these models is have a human supervision on top of that. So we always think about models as augmenters, not as decision makers. And that's where we find value. Yeah, that's the art of data science, I would say. You have to basically solve that problem case by case basis on the long term versus short term part. Yeah. Yeah, I did have a few use cases that probably I can talk about from the previous slide. One of the areas where we have seen great value is this model predictive control. Okay, so if you work in manufacturing with PLCs, they have this thing called PIDs, which are basically the optimizers of process. And one of the things that we have done is we have deployed these models which basically make decisions in a predictive way as against the reactive way of PIDs. And by putting that, we have seen great value where if we have, if we know that there is a change in the process happening, we can actually make the change accordingly ahead of time before the change happens. So, and that way we can save a lot of energy or a lot of raw material cost. Yeah, we give, in many cases, we have these models running every 30 seconds, every minute, and they give recommendations to the operators. We don't, at this point, go and make change directly. As I mentioned, we always have human in the loop, so human ultimately make decisions, but we give recommendations for the parameters. And the human many times just has to press accept button, and those parameters go in the machine. All right? Yeah, sorry. Yeah, so that's where the AI-enabled predictive maintenance comes in. We actually have models currently running in production, which actually try to understand, they have learned patterns from the past about failures, and then they make recommendations based on kind of like, if they see the patterns again, they make the recommendations that there is something wrong, go and change this part. So we have connected with the FMEA in manufacturing, and that helps us to actually make proactive change before failure. Okay, I think we are out of time, but thank you all for your attendance.
know, it's like I should start one. Standing on something that's like a little squishy. All right. Hello, everyone. We're just, giving people a few minutes to roll in. Looks like there's something exciting being rolled over there. But we are Data Robot and RxA today. We're going to talk to you a little bit about what we do, how we implement it, walk through a use case together, and talk through what's, a little teaser of what's coming next. So that the goal is, how can we accelerate the machine learning lifecycle for any business that wants to just incrementally and rapidly increase their ability to solve business problems. Today, I am presenting up here with Jack up here. I'm a lead data scientist at Data Robot. I've been in the field for about a decade now, and I've worked at Data Robot specifically for about 6 years, 6.5 now. And Jack, do you want to?
Yeah, I'm Jack Clarity. I'm a senior data scientist at RxA. It's a consulting firm partnered with Data Robot. We've done a bunch of Data Robot implementations. We love the product. So yeah, I'm a big nerd for this Data Robot project, which you'll see soon.
All right. So I haven't really talked to you about Data Robot at all much, unless you've come by the booth earlier in the last day or so. I wanted to talk to you a little bit about, frame their problem and talk about the data science landscape today. Starting off, there's a lot of challenges, I'm sure, as everyone's aware. I think I've talked to a few of you, but do you mind giving a show of hands how many people here are practitioners versus how many people are stakeholders? I guess, practitioners? Wow, wonderful, love this. Stakeholders? Cool, very cool. As all practitioners know, data science work, it's fun, absolutely, but it's an iterative process. There's not enough of you for any given job posting that you see post on LinkedIn or on like Indeed or any of those postings. You'll immediately get flooded with all of these candidates that just, they're learning, they're out of school, and it's it can be a little hard to find the right data scientists. The work itself can be slow because it is iterative. You can't say, I will start with A, I will end with B. Throughout the way, you always end up with some, there's always something that changes over the line. And because the work is slow and because the data science field is really, really hot right now, you can get really high turnover. So for the business stakeholders out there, trying to restart projects as people come and go does really slow down the process. And in terms of how we want to tackle that, at Data Robot, we're a data science platform focused on accelerating that cycle and helping both the data scientist practitioners as well as the business stakeholders have a better grasp on what their data science team is doing, what the entire life cycle is, and the reason how we're able to do that is, once I advance the slide, focus on two main focuses within DataRobot. So DataRobot is a platform that sits on top of your data. You already have your data platform, whether that be Snowflake or whether that be Azure, Databricks. DataRobot sits on top of that and consists of two main phases where you experiment. You want to build those models. You want to iteratively approach, how do I add in different data sets? How do I construct the data set in the way that actually answers the business problem at hand? How do I optimize it? How do I test different approaches? Once you get to something that is explainable, that is applicable to the business, now you want to move that into production. So how can we start taking this model that you've poured your heart and soul into, how do we get that into production grade endpoint? How can we monitor that over time and track whether or not anything's drifting, whether or not you need to start retraining that model, if the ways that people are using it has been changing over time? Those are all important factors for you to monitor while it's in production. So all of this is also pulled back into your data platform. So you always have that system of record that holds both your initial starting data as well as contains the predictions and how it's being used in production. This can all be connected through different sorts of applications. This can be applied into, either your internal applications or into something that is customer facing, however that needs to be applied. And in terms of what we actually do at DataRobot, this is how we do it. Our focus is on the software, but today RxA is with us because they are one of our strategic partners here at DataRobot, and they're here to help accelerate any companies who want to just move a little bit faster. Using the DataRobot platform, how can we accelerate the work that we're doing in data science?
All right, thank you. So yeah, it's great to hear about all the wonderful things that the platform does, but I think the best way to do it is actually see it in practice. So we want to run through a use case we did along with Ford Direct and DataRobot of creating a propensity to buy model. So they have a bunch of data. They want to figure out, hey, who is likely to buy a vehicle in 90 days? So first, who are we? So RxA is an analytics consultant division of One Magnify. We are partnered with DataRobot. We do a lot of things on the BI cycle, all the way from just business intelligence all the way to predictive analytics and looking at the cutting edge stuff like generative AI, making developments in there, which we will touch on coming up in a little bit. But looking at this use case with Ford Direct. So first, what data do we have? So this is an automotive use case. So if you even thought about buying a car at any point in time, the auto companies have data on you. So there's a ton of data in this space, right? We have in-person sales and service, web activity, and leads submitted, as well as email and phone communication. Now, this is one of my favorite stock images of all time because you can see in this middle picture, whoever's on the website is definitely looking for a car because they put a toy car on their keyboard. I don't know what the logic there is, but it makes sense for this slide. So we have all this data, right? We have actions by customer. And what we want to do is roll that all up to the customer level so we can make a prediction. Now, normally that takes a ton of time, but this is where DataRobot comes in. The first time-saving feature that we saw was this automated data aggregation. So I have my actions data set, which was 5.6 million rows of data, and I wanted to roll it up to the customer level. Now, normally I would have to do this manually, go through, find out how I want to aggregate this data. DataRobot does this automatically. Automatically rolls up my features, creates, in this case, created 257 derived features for me. Now, I'm a thorough data scientist, but I don't think I will be sitting and creating 257 features if I did this by myself. So not only did it do it faster, but it did it more efficiently and created better features for me to use for my modeling. Secondly, a lot of things, this is a trend in DataRobot, it's still customizable. So even though it's automated, there's still a ton of areas for the data scientists to kind of get their hands on, change some things. So here it let us change custom windows of timestamps of like how far back do I want to aggregate this data. I ended up using actually multiple different timestamps here because that's what ended up giving me the best performance. So really cool tool there. So already some great time savings before we get into modeling. Now I have these 257 features ready to go to modeling. DataRobot says, hold on, we're going to do this data readiness assessment for you. So what it does is it's going to look at all my data, look for outliers, look for inliers, other potential problems that they see in my data set. And the number one thing it looks for is this target leakage. So target leakage is when you have a feature that's kind of giving away your answer in your data set. So it makes for really great models, but then when you actually put those models in production, they're useless because it's using data that it's not supposed to have. Many data scientists have a horror story revolving around target leakage. I know to talk to someone, it's like you have a model that had target leakage, you didn't identify it, and it goes up this chain of like you tell your boss, who tells their boss, who tells the CEO of like, oh, we have this model, it's 97% accurate, it's awesome. And then you find out your model had target leakage and you have to go up the chain and be like, no, it's still good, but it's not 97% accurate. And then yeah, the string of apologies that have to come through. So DataRobot finds this automatically. And this is huge because it happens right at the start before I even created a model. So this is a huge time save. So in this use case, it actually flagged this prediction point hour of the day as target leakage. So normally I probably wouldn't even think that makes sense. I mean, that's a feature I should be able to use. But then with one click of a button, DataRobot has this really nice histogram, shows me that actually all of my sales are happening between 4 and 5 a.m. So this is actually just because of the way the data was batched in. The sales come in at 4, 5 a.m., and then the model only has to look at this and be like, oh, I can get 100% accurate if who bought a car. So this is something that maybe I catch it, maybe I don't, and if I don't catch it, I could spend weeks of work wasted because I didn't catch this small thing that DataRobot's going to do automatically, and then I actually removes this from any models that I try to make, so it won't let me put it into the model. So now that my data is ready, got rid of that target leakage, dealt with any of the outliers that might have been in that data, we're ready to do automatic modeling. So DataRobot's going to automatically train a bunch of different models, changing the model type, changing those parameters. And they do it so really intelligently in a smart way, so you're not just sinking a bunch of resources there. But it's going to create all of these models, in this case, 203 models trained automatically, and then rank those models by a metric that I choose, and then I can see what models are performing the best. Now, when I first heard about DataRobot, I was a little concerned that, automated data modeling, like it's going to be a black box. I'm not going to know what's happening inside of this. But that's not the case. So with one click, every single one of these models has a blueprint associated with it, which is telling you exactly what's happening from data all the way to modeling. And to that point, each of these also has really extensive documentation alongside of it. So if I'm ever like, I forgot what an extreme gradient boosted trees classifier is, I can click into the documentation, get a really nice summary of what that model is doing. So I have a lot of confidence in what's happening, and I can go forward that this model is a legit good model. The other thing is this is fully customizable. So I can see like, okay, this took my data, it imputed missing values from my numeric variable. Well, if there's a certain way that I wanted that to happen, I can actually go in, change this, and it's going to create a new model that's going to go back to that leaderboard, and I can see how that change affected that model overall and see if it's either improved or not improved the model. So again, looking at the results, again, we're trying to predict customers who are likely to buy with all this data. And looking at the results, we did very well, and DataRobot models were very successful in doing that. So $6.5 million of value every 90 days that we're able to identify with this model. It does that by figuring out what the highest likelihood of customers to buy is. So 80% of our buys were in the top 20% of our customers scored. So you can see this chart here of our density of the red is our no buy customers and the blue is our buy customers. We're able to identify kind of, these are the customers that are most likely to buy and 10 times more likely to purchase a vehicle at the high end. So what does that mean overall? So we've had this in production for over a year now. We score every customer that has a new action. So we get this changed every day. So we can see customers change in their propensity every single day and start to do some really cool stuff with that. And then we're using this to create audiences that enable us to, and the dealerships to kind of identify who's the most likely to buy and then target dealer or target customers exactly when they should be targeted. And then the impact, this actually replaced a kind of tech debt, $3 million technology that Ford Direct had, and all while providing a more successful targeting campaign with this model. And it's also laying the groundwork for using a custom solution with generative AI. So we're going to use this model and insights driven from this model into a generative AI solution, which we're really excited about. And then, yeah, perfect. What's next? Generative AI, of course.
topic that none of us can get away from as it is. I'm sure you've all heard plenty about it over the last day and a half. Everyone is talking about it in the field. What is generative AI? Like, how can we create real business value out of this? What does this actually mean? Let me talk about what it means for Data Robot. We've talked through a really interesting predictive use case here. Now, how can we start layering that generative component? So our goal at Data Robot is, with everything that we do, we want to be interoperable. Whatever cloud you're working with, whatever algorithm you're working with, wherever your data lives, we want to help you orchestrate that whole pipeline. So if you think about the 3 steps here, where you're synthesizing your approach, you're bringing everything together, you want to have it running in production behind some sort of production-grade endpoint, track and monitor that over time, and make sure that application is being served out to the end users in whatever fashion, or whether that be internal, external, et cetera. These technologies are changing so quickly. As I'm sure you're aware, different LLMs are being announced every single day. Different vector databases are being announced every single day. Every other day, I see a new article about, new prompting strategies. How do we do prompt engineering? Really interesting new embeddings. Like, I love the topic of embeddings personally. Like, this is so fascinating to me, this entire subject. But there's this field of generative AI is just changing so quickly. It can end up in sprawl, and you all of a sudden need to have 50 different services, and you have to be able to bring them all together into one cohesive solution. So with Data Robot, the goal is bring it all in, orchestrate it, and get it into production quickly. What Jack talked to just now was taking that predictive element where we're saying who are the people who are most likely to purchase a car, and we also now want to start layering generative AI onto it. Something that I think has really the most opportunity here is bringing the generative and the predictive components together, because it's not just about building a chat app. It's about being able to do something, make a prediction with that. How can we improve this over time? How can we make sure that your predictive AI has some sort of generative aspect to make it easier for your end users? How do we make sure that our generative solutions have some sort of prediction driving them moving forward? So as we're exploring this space of generative AI, I feel like everyone's exploring this together. We need to make sure to think about where can we find this overlap and ensure that there's true business value being created out of it. And finally, I want to wrap with this information on, ways that you can monitor your generative components over time. This really comes down to, there's a lot of different services out there, as I said. You want to make sure that these services are all being monitored and governed over time. I think at least a few different speeches today or talks have talked about being responsible with your AI. So you want to make sure that whatever is in production, there's governance in play, there's retraining in play, that there's a way to be, to guard either the inputs coming in or guard the outputs coming out. So this all does need to be in, you need a true pipeline around this rather than building a solution on your laptop and putting it out into like a Streamlit app, which is wonderful workflow, but does not work for businesses. All right, I think that brings us to the end. Generative AI, if anyone wants to come talk to us, I love talking about this subject and talking about how we can actually bring this to real life. And Jack is here to talk about how can we accelerate that entire process. Well, yes, if you want to come talk to us, we'll be here. Also, we're in booth 119 downstairs by the candy bar. And we will also be doing a panel today in the center stage at 1:50 this afternoon. Thank you.
Right. Testing 1, 2, 3. All right. It is bright here. All right, let's get started. I know we're 20 minutes in just before lunch, so we'll get through one more topic for you guys. And this one's all about foundational strategies for AI-powered data democratization. So let's get right into it. For those who were not at the keynote yesterday, my name is Naveen Sharma. I'm the VP of Product at Stardog, a enterprise knowledge graph platform. And today's topic covers a little more in depth, at least a perspective that we want to bring to you guys as to the audience in terms of how you should be preparing for Gen AI inside of your enterprise. When we talk about data democratization, we all know it's ultimately our end goal is to enable all employees inside the enterprise to be more data informed and have the ability to use data techniques to resolve critical challenges inside of the business. And for us, that fundamentally boils down to where most organizations fall short in terms of being prepared to take advantage of this upcoming innovation. And that translates loosely to points of friction that we find in a lot of areas inside the enterprise. And I think about this in terms of these 5 categories, right? You think about the culture, the culture that we've come from, which has all been around big data. So there's been a lot of focus on data collection. There's been a lot of focus on data centralization. There's been a lot of focus on control in the hands of a few specialists inside the enterprise that have the right skill sets. Data models have traditionally been very tightly coupled with how data is stored and the data storage infrastructure behind it. Data integration has been about ELT and ETL pipelines, physically copying and moving data. Data interrogation has all been about asking the questions you want to know up front and putting the queries together to deliver back to the business. And data intelligence has been more focused on sort of this passive collection of metadata, right, inside of some sort of a data catalog. And if this should be a representative of what most organizations have been doing in the past many years. And from our perspective, and again, this is a point of view, and how we see our vision shaping for our product, our platform, and what we believe organizations should be thinking about from an opportunity perspective, is shifting that culture away from big data to we call wide data, i.e., we are here in an era where data is going to be attached to its systems of records and interactions and engagements, and that's where data lives, and that's tied to the business process, and that's where context lives. And so we want the ability to have this sort of wide data connection established where we can federate access over that information and enable ultimately a culture of data sharing. When we talk about data models need to be abstracted away from where the data is ultimately stored. And why that's important is because that is how you're able to put multiple lenses in the data, shape data in ways that you want to drive your analytical insights and not have to go back to underlying infrastructure to reshape, remodel, and change the physical aspects of the underlying data storage. And having that abstracted data model have business meaning attached to it, ultimately it helps the consumers of that information be more intelligent with the information and what they can do with it. Data integration, yes, a lot of times we do not have a choice. We do have to physically copy data. But if we can limit the amount of data sprawl by leaving data in place, using techniques like data virtualization to federate access over that data so that we can get access to up-to-date information at the time we query for the information, is a much better opportunity that is presented in front of us. And data interrogation needs to be about more data exploration, complex query processing, search, discovery. That is how you enable more citizen data users inside the enterprise to get the benefit of interrogating data in ways that they may not know all the questions they want to ask up front. So you want to be able to enable this type of data interrogation and querying. And data intelligence is all around this sort of notion of combining metadata with the actual data, so you're able to infer relationships and drive recommendations back to the people that are actually asking the questions. So by combining metadata with the actual data, so that you're not just looking at a passive data catalog of metadata, but you're actually bringing that metadata in at the time you're querying for information against the concepts that you're defining in your abstracted data models, helps you understand what information is available inside the enterprise that you can infer from the types of questions that are being asked, so that you can present that and recommend that back to the user. So if those opportunities align with the vision that you have or should have, then it should be noted. This is essentially what Gartner has been talking about as part of their data fabric architecture for the past 2-3 years. And at the core of this data fabric architecture, they talk about how do you shift the focus from data producers to data consumers. Right? This is where the idea of knowledge graph and semantic enrichment becomes fundamental to the actual technology architecture for a modern data foundation that needs to be inside of an enterprise. And this is the same foundation that will help you get ready as you start to think about Gen AI and bringing that back to the enterprise. Now, how many of you know this notion of semantic enrichment? Is that a concept that you're familiar with? Yes, a few of you, yeah? Why don't we make this real in terms of an actual simple example? And ultimately, what we're really trying to do is understand the organizational metadata, that is data about all the data that exists in the enterprise, and enriching that semantically to deliver some new insights back to the enterprise. So let's take an example. What does that mean? I have a data set. It's about the British royal family. Everyone's kind of familiar with this, right? We have the members of the royals, all the way from King Charles up in the top to their kids, Prince Williams and Prince Harry, and of course their kids down below, which is Prince George of Wales and Princess Charlotte. And the two data sets are represented as relational tables, right? One table has their ID, their name, and their gender, and another joint table has that parent-child relationship. So typical relational database, two tables, kind of articulating how these members relate to each other. Now, what we see this in terms of actual technical metadata, we have a person ID, we have a full name, we have gender, we have a parent ID, we have a child ID. And if we want to represent this in sort of a conceptual data model, it's a member has a relationship with another member in terms of a parent-child. Very simple model based on the actual tables that exist. Now, in the real world, of course, we're interested in more than just the parent and the child relationship, right? We want to know who's the grandmother. We want to know who are the siblings. We want to know who the uncles are. We want to know who are the parents of those maternal uncles. And your choices kind of come down to, let's reshape the data to answer these questions, which means we now have to create more tables, more table joins, change the underlying data model. Or maybe we want to create some complex data pipelines as part of our ELT processes to be able to answer these questions. Or, I posit that there is another option, and that's option C, which is how could we semantically enrich information on top of our actual underlying data, which is the two relational tables, to answer these questions without having to go reshape the data or build complex data pipelines. And the way we do that is actually representing what you see on the left as the actual schema, which is abstracted away from the underlying source. Now in this case, I've given you an example of a source of the tables existing in Databricks, right? So it's a Databricks environment, could be SQL Server, could be Postgres, really doesn't matter. So those set of two tables sit there, they're mapped to the concept member, but I've also created a couple of new relationships that are defined here as part of this abstracted data model. So I'm putting a lens on top of that data in the way I want to consume this information. So that's step number one. Number two is I now want to be able to infer those relationships based on domain-specific rules. So this is their domain-specific rules come into play. In this context, we're talking about the royal family, but it could be financial services, banking, insurance, pharma. You can think about domain-specific rules for specific business functions. It really doesn't matter. you're able to now annotate those rules on top of this data model, just in terms of specifying how you would, in defining how these relationships are actually spelled out, which is if a person has a child, then that person is a parent. A grandparent is the parent of a parent. The male sibling of a parent is the uncle of the child, right? So these are if this, then infer, that's the relationship. So when you annotate that on top of the data model, this is the actual semantic enrichment via the notion of inference. I can now ask questions from that data set, the original data set of the two tables, like who is Harry's grandmother? And I get back the answer, Queen Elizabeth II. I did not change the underlying data source or the data model. I did not create any complex ETL pipelines. I was able to ask these questions based on the semantic model that was abstracted away and then annotated by these domain-specific rules. Now, this is an easy question to ask. What if I wanted to ask something more complex? Show me all of Harry's relationships, cousins, siblings, grandmothers, children, parent. What I'm able to do and ask that question, and I can get a list. Of course, you see it's a big list, but a represented answer on the left kind of shows you all the relationships, from parent to child to members, in terms of cousins to siblings and grandmother. And this is the power of adding semantic enrichment on top of your data landscape, so you can enable your consuming applications, but also more importantly, your consumers to ask questions of that data in different ways that helps them do their job better, without having to go back and reshape your data and remodel everything from scratch just to be able to fulfill this need. And they can go ahead and explore and visualize and drill down to understand these relationships. So same new insights in the same data. And of course, knowledge graphs have now become a major enabler of any data and analytics initiative. In fact, when Gartner released this 2023 Impact Radar, one of the things they called out was this idea that by 2024, companies that use graphs and semantic approaches for natural language technology projects are going to have 75% less AI-based technical debt than those that do not, right? And we believe that to be the case because this is going to be a critical driver as you start to onboard Gen AI inside of your own enterprise applications, and you start to think about how does that data management lifecycle now translate to this next generation of application that's going to be powered by Gen AI, right? So everything from what is the right data that I want to be able to train my models on? How do I prep that information with the foundational models in terms of training and fine-tuning? How do I describe the right prompts and embed those prompts based on my enterprise data? And ultimately, what we're doing here is providing a mechanism through which you establish a structured, standardized data vocabulary for your enterprise data. And that's what you use to ultimately train your large language models to drive the actual applications so that you reduce any hallucinations, you eliminate any hallucinations that we all know exist in some of these foundational models. Ultimately, our goal is to turn what we had earlier, this notion of metadata and semantic enrichment to deliver insight. We now power that by AI to actually make that insight happen faster, right? So ultimate goal is what? Still to democratize data and information for the masses inside the enterprise. It's your customer service teams, it's your sales and marketing teams, it's your product and R&D teams. And we are at the preface, we are actually in those early days of working to make knowledge graphs a key critical component of every large language model initiative inside the organization. And you will see a demonstration of this happen later this afternoon at 2 o'clock live. My product manager, Laura, will be doing that demonstration down at the Vinyl. If you have an opportunity to stop by, please do so. And the way we're thinking about it is ultimately data democratization is when we can have someone ask a natural language question and then have a natural language response go back to them. And what I'm showing you here is, based on our early access information, the description that came live from people that raised their hands that wanted to be part of this early access in terms of what they wanted to do with this. They want a customer query interface. They want a simpler way to ask questions of the data. They want natural language queries to quickly find information. answer natural language questions, interact with cancer genetic text, right? So you can see people from various industries asking these types of questions, and an interface that allows them to do just that. Now, what is happening with Stardog VoiceBox is we are taking that natural language question, we are embedding that based on the ontology, i.e. that abstracted data model I showed you, embedding that data model into the text that goes into the large language model service that then produces the query that has the mapping back to the source to get the actual data back and present that back to the user in terms of a natural language response. And that round trip is all managed and done in a way that when you get a response, you can also go back and have full explainability around how that response was actually generated. Right? So if I go back here, I can actually see the whole idea of linking this back to what generated that based on the question that was asked. Where is that information coming from? What concepts raised that? What concepts were mapped to the sources that presented that results for us, right? So there's full explainability behind this, which is a key component of building trust with the responses that come back. So with that, I would encourage you guys to stop by this 2 o'clock session down at the Vinyl, and happy to take any questions. Thank you. Enjoy your lunch.
Hel- Hi, everyone. Just a quick announcement. I wanted to remind you guys we have our data marketplace over here. So bring your lunch in there, meet our partners. There's also an iced coffee bar that will be in there all day, too. So enjoy lunch. Another Atlanta staple. Oh.
Hello. Hey. All right, everybody. I know we were finishing up with lunch, but I'm going to jump in to our next session this afternoon. My name's Tyler. My background is in machine learning engineering, and I get the pleasure to talk today about two things that I'm incredibly passionate about, which are using LLMs and caching. And so by quick show of hands, and I'm just curious to see how this plays out, how many people here would think they know a thing or two about caching? Raise your hand. Okay, that's probably kind of what I expected. And then now, those of you here that maybe know a thing or two about LLMs or want to know a thing or two, okay, got it. So we're in a good space here. This talk is called LLMs and Caching Better Together. What we're going to do is we're going to talk about why, what, and how for caching specifically. And then we're going to try to talk about LLM application design from the standpoint of going to production. And then we're going to talk about how caching can help influence this. So this is like a really simple statement. You guys should all probably relate to this if you're a developer, an engineering leader, or even an end user of an application. Latency is a new form of downtime. This is measurable in many different ways, especially in e-commerce, and I'll point to that in a second. But how many people are frustrated when you go to Google or you go to some search engine? It takes forever at times, or you're waiting for the Domino's pizza tracker to actually get to the end. Latency is a format of downtime that we can now measure. And so during the pandemic, a couple groups, I think Couchbase was one, Deloitte was another, that did some studies to try to measure the impact of real-time applications on our day-to-day life and even the way that we do business. And so one of the things that was interesting was around 95% of enterprises have already started to try to find ways to modernize their data stack. And part of that is because, as you can imagine, during the pandemic, we started relating to each other online, more goods and services and products were sold online. And so that created this environment where the change was necessary. The other thing that I thought was really interesting from these studies was one, you can actually measure down to 1/10 of a second, so 100 milliseconds, the impact that it would have on an e-commerce or retail experience for a shopper. And that's measurable down to the order value, for example. And so it's not just as easy as saying, hey, speed it up, make it faster, right? We all probably understand that, we probably get that. The reality is that if you're trying to build a system that can scale, you have to deal with latency, inability to scale. You have to deal with the resiliency of the database that you're working with, or whatever the data layer is in your case. So these are the things that we've noticed, and it's part of the reason why caching has become a common strategy. It's not the only strategy, it's not the only solution out there, but caching is a way to speed up your systems. And there's a number of common solutions out there. There's a bunch of literature that people are publishing about strategies for caching. I'm going to highlight two of them as a way for us to kind of, again, get on the same page about what caching is, how it works. But a number of these can be used to either speed up reads or writes to your data layer of choice. So we're going to talk about the cache aside pattern. And again, I'm going to kind of frame it like we don't need to be experts in caching in this room, but I do want to make sure we're all level set as far as what caching is to begin with. And so cache aside is a way that you can essentially slide a cache database next to your application, next to your slower database, bigger database. And the way it works is that your application might need to make a request for some information, like run a query. And so the first thing you do is you actually quickly check the cache to see, hey, have I already processed this request? Do I already have this information stored that I can just quickly pull out? And with the speed of a cache like Redis, for example, you can achieve that in sub-millisecond latency. So think about the user experience on the other side, right? You log onto an e-commerce site, and it immediately remembers the last couple items that you were looking at, right? That's not done by accident. It's intentional, right, to make sure that you have a good experience. In this particular design, if you don't find it in the cache with cache aside, you then have to make a query to the database of record, which is totally fine. This is an acceptable risk that you take on with the cache aside pattern. The second pattern I want to talk about is prefetching. This is a little bit different. This works in the way where you have basically a write path and you have a read path. And so in this case, you might be writing all of your data to your system of record, your larger, slower database. But then you use something like a CDC technology, like change data capture, that can continuously replicate data between your slower database and your cache. And this is useful if you need to actually keep all of your information in your cache and make sure it's always up to date. And again, this influences the way that we can experience applications from the end user perspective. Another, e-commerce is always a great example here, right? So as soon as you log into, or maybe go to like Sephora or Ulta Beauty, for example, it can always remember, the different pieces in the product catalog that you've looked at recently, or items that are potentially on the category landing page. And so that way you're not having to go back to your slower database every single time you load that page. So this is kind of now the interesting point, right? It's like, how can we apply similar solutions that we've learned about the need for speed and how caching can support that with large language models? And this is kind of an emerging area for us at Redis. We're obviously researching this a ton, but also with customers and users that are in production or trying to get to production with chatbots and virtual agents and knowledge assistants. And so obviously you can see a couple popular LLM logos up there, right? So almost every single week, every day, it feels like there's a new large language model provider coming out with a solution. They claim to be better performant, faster, cheaper, open source, proprietary, third party. But this is kind of what we think of when we think of an LLM application like a virtual knowledge assistant. I think a lot of us have in our mind that this is sort of what it looks like, right? There's some human input that comes into the equation. And then there's an application that processes it, maybe talks to some AI model, a machine learning model, maybe an LLM in this case, and then does something, right, and sends it back. And we're like, hey, we're done, we're good. But the reality is, even if you just look at this, there's already opportunities for latency to be introduced into this pipeline. Just the network calls alone, getting data back and forth, and also on the actual server itself for the application, and for where the model is itself. But the reality is something a little bit different. And this is actually mined from a partnership we've had with one customer, helping them try to get to production with an LLM application. You can't even read all these because there's so many things going on, but I think you can start to see the pattern, right? It actually takes a lot more things to be included into the production deployment for it to actually work. And so it's not just, hey, let me take this query, let me send something to a vector database to retrieve some data and send it to an LLM. There's actually a ton of pieces in here. There's an experimentation route, right? You need to be able to do A/B testing as part of this to make sure that as you roll out changes, it's not influencing negative behavior with internal users or external users. There's different data pathways for knowledge. So like maybe you have a knowledge graph, right? We've heard a couple talks about knowledge graphs here. You might have a pathway for a vector database. You might have data processing pipelines for all of your actual knowledge data, your internal enterprise documents. You might have external APIs that need to be called as tools as part of an agent process. You might have logging infrastructure, right? You need logging infrastructure to make sure that users are talking and asking questions that are appropriate. And on the same note, as far as like monitoring goes, you need to have input and output validation as part of the process too, to make sure that things are fair, and questions are being answered safely and securely. So there's a ton of different processes that have to happen here to bring something to production. And so it's a little bit difficult, right, to try to pinpoint anywhere on here that we can try to optimize, because it's a little bit overwhelming. So we're actually just going to simplify this from this point forward, which is, what if you already know the answer to the question? And when I say the question, I think what I'm really talking about is the user input. So you go to ChatGPT or you go to some other chatbot application and you ask it, hey, like, I'm in the field, how do I reset this system code after an alarm is going off? Maybe you're a technician and you've got a smart virtual assistant in your phone, and it answers the question for you, right? This application probably has access to your product documentation, probably has access to some LLM like GPT-4, and it was able to assemble an answer using the process called RAG, or Retrieval Augmented Generation. We've heard about that in a couple different talks here. And so the reality is this box in red, actually, if it's validated and if it's a good answer and the user says, hey, yeah, that's exactly how it works, then we know that as knowledge that's been generated, we should be able to take advantage of for the future. And this is interesting when it comes to human language, because if you look at these other questions, these are all ways to ask the exact same thing, right? Users are using different words to express their question, but they're actually asking the exact same thing if you boil it down to the core thing. And this is another function for which a vector database can fall into and be useful. It's not just for RAG, it's not just for retrieving core contextual knowledge for your application, but it can actually be used with the semantic search capabilities that are part of a vector database to compare whether questions that have been asked in the past by yourself, by other users in the system, are similar enough to something that you're asking right now, and you can actually take advantage of that generated knowledge. Because you've spent money on that, right? Like you've spent money on the API calls to OpenAI. You spent money on the API calls to get embeddings, to create vector embeddings from your raw data. And so all of those things you should be able to take advantage of for future iterations and for future invocations. And this is all possible, again, because of semantic search. For those of you, I'm going to give you like kind of the 30-second version of semantic search, which is basically the ability to take your unstructured forms of data, like, whoops, apologies. Oop. Great, so now you're seeing kind of the, the end of all of this. It's the ability to take all of your unstructured data, like text, images, video, and use some of the advancements in NLP and computer vision and the foundation models that have been trained thanks to the transformer architecture, which actually one of my colleagues did a nice talk on yesterday. We learned about encoder and decoder transformers. And so with those models, you can create a vector embedding that represents your data and store them in what's called a vector database. And from there, you can then compare that data in near real time to find similar entries. Now, of course, we all think about knowledge retrieval, contextual retrieval, or RAG as kind of the primary use case. But with caching, what we're able to do is check to see if a similar question has been asked before. It's actually a really simple concept, right? And this is kind of the flow of what it could look like if you're able to take advantage of a cache as part of your RAG application, whether it's a chatbot. So the first thing that happens is a user asks a question. There's a prompt that goes into the system. Right after that happens, there's basically this embedding step where you talk to some external API or service provider to create a vector from that piece of text. And then next, and this is the most important piece, you can see this is kind of the gate to the entire flow, is you can check, hey, with a certain amount of, we'll call it certainty or surety, can we check, has any question been asked before that is similar enough to the thing that the current user is asking about? And if the answer is yes, you can see that this becomes a lot simpler, right? You can actually short circuit every piece in this process because you're able to validate that this is like within bounds and that this is something we actually can use previously generated knowledge to get to the solution faster. And if you don't, and you have a cache miss, if there's not something that's been similarly asked, then you then have to go through the entire process, right? So you would have to do some validation to make sure that this question is appropriate. One of my colleagues, Alan, gave a talk yesterday where I think he talked about, hey, if you're like a financial services company, you have a chatbot, and someone comes in and asks about aliens, we probably want to be able to know right away, hey, this is like outside of bounds, right? Like we don't talk about that. We're a financial services company. We can help you make movements on your stocks, but we're not going to talk about aliens. So we need to have a way to semantically check, is this a question that is actually within our like scope of knowledge, right, that we're trying to present. Secondly, then you need to retrieve your relevant knowledge documents. It could be from a vector database, it could be from a knowledge graph, it could be from other sources. And then you also probably need to enrich the prompt with contextual information about recent conversation history. So if this user is, sharing information like their name and kind of what they're after, you want to make sure that the LLM, which by the way is stateless, has some access to that previous conversation history and be able to actually have a better chance at being a little bit more personal and answering the question appropriately. And so all of this leads to our grounded prompt that we pass to the great LLM, and we get the answer back. But as you can imagine, multiple steps there, right? Some of those are slower than others, and some of them actually have a cost or a dollar sign associated with it. And so every time you miss a cache hit, you have to take on that extra cost. And so I normally don't love showing like code on slides. I thought because this is such a simple topic, I would go ahead and show kind of actually how you can get started with this today. How many of you are familiar with a tool called LangChain? Okay, cool. So LangChain's super easy. You can pip install LangChain in any Python. They also have a JavaScript environment too. And with just a couple lines of code, you can actually take this particular framework and stick a cache in front of every single LLM chain or agent that you build. And so this becomes automatic, right? You don't even have to actually do anything beyond what you see here. There's another route to do this. If you don't want to use something like LangChain, you can use our purpose-built vector library called RedSVL. Similarly, it's a really simple way to add a semantic cache in front of your LLM calls. And so I think it's also important to spend a little bit of time on this slide. I know I kind of accidentally I let the cat out of the bag too early, but It's not always the case that you need semantic hashing. I just want to make that incredibly clear. I don't want to be prescriptive and actually say that when you're building these, you need it. In cases when you have frequently asked questions, or you have really large user bases with a high volume of requests, or cases when you have a strong emphasis on content moderation, so making sure that the LLM is not generating either hallucinations or there's not a ton of variance between responses. If you fall in any of these three buckets as you're trying to build chatbots, then this is probably something worth exploring. Really, the benefits of it are cutting costs associated with every single API call you would need to make and improving the throughput of your system in total. And so the other thing I want to highlight is OpenAI has put out a nice guide on production best practices. And one of the sections in here is all about improving latency. You'll actually see they talk about caching in a similar kind of way as one route. There's a couple other routes in there. And I think it's important also to keep in mind that caching may seem like a really simple solution, but there's actually a lot more thought that needs to be put into it. Because what if you cache the wrong answer? What if the answer that you generated from the LLM is actually not factual? It has hallucinations as part of it, or it's inappropriate. So there's still a need to have auditing, there's still a need to have live monitoring to make sure that things aren't going off the rails. It's also important that still at this stage where we are in kind of innovation journey, that a human is still in the loop. I don't think it's going to be too long before we're going to start to have better automatic evaluation methods. Some of those techniques are already coming out right now. There's one called RAGAS, R-A-G-A-S, that is rather new. And there's some investment being put into the community to try to figure out, hey, can we use other LLMs, for example, to monitor and grade the quality of responses we're getting from these systems? So this is really kind of the end. There's a couple links here to the LangChain docs that we saw earlier, also docs to the Redis documentation there. Of course, I'm here on LinkedIn. You can also try to find me there. And I'll be around after. Feel free to come and ask questions about caching and LLMs and trying to put this stuff into production. Awesome. Thank you.
Hey, 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 check. Hey, hey.
Testing. Hello. Welcome. Okay. Awesome. Well, hello and welcome. And I'm glad the national alert went off a little bit early, so we didn't need to pause and wait for that to finish. So my name's Laura Fiery Monroe, and I'll be talking about where knowledge graphs and LLMs collide. Promise that'll be my only corny joke about colliding this presentation. Before we get started, I'm going to focus on just a little bit on what is an enterprise knowledge graph. And so an enterprise knowledge graph is a semantic data layer that sits across your data ecosystem and connects that ecosystem with business context. A knowledge graph was built to unify data, and using the fact that data is naturally connected, a graph is a wonderful way to represent those connections. Without likely even knowing it, you've been using knowledge graphs and tools. Many of the search tools that we're all very familiar with are based off of data being held in a knowledge graph. We'll also cover a few definitions for terms we're likely all very familiar with now, but just level setting on those definitions. So for a large language model, typically a large language model is a type of artificial intelligence that is using deep learning techniques and massively large data sets to understand, summarize, generate, predict new content. And it's primarily focused on text. For generative AI, this is a broader application of artificial intelligence than singularly large language models, and that describes algorithms such as those that we're familiar with through ChatGPT that can be used to create new content, whether that be audio, code, video, images, as well as text. So generative AI is that broader sense, and so I just wanted to cover a quick overview of those two terms. And so you'll notice that neither of those definitions for Gen AI or LLMs cover data accuracy. And that's what we're finding many users that are starting to use these tools, especially within an enterprise landscape, are struggling with how confident and how accurate are those responses from these tools going to be. How can they validate the responses, or how can they prompt to a valid response? And all of that being without spending more time and effort than just manually doing the tasks that they're asking an LLM to do. And so that's where, when you combine a large language model being backed by a knowledge graph, you're going to have more data accuracy, because the large language model is going to be used to generate a query against that knowledge graph, rather than focusing on answering the user's question directly. And so instead of combining text that potentially is meaningful when combined together versus just is high frequency of that happening, it's going to be generating an accurate, verifiable, understandable query against a known data set, which is your knowledge graph. And so with that, I'll introduce Stardog VoiceBox, which is an LLM produced by Stardog against the Stardog Enterprise Knowledge Graph. VoiceBox provides a conversational interface for helping you build a data model, which is one of the foundations of a knowledge graph, as well as creating complex queries against your knowledge graph. And it can do so in a way that is transparent, iterative, and of course, providing that context for its decisions, which you can then go through and debug yourself if needed. Talking a little bit about the architecture of Stardog VoiceBox here. The core of VoiceBox is going to be coming from your knowledge graph. Your knowledge graph is then used to build an embedding model. That embedding model is then used by both a vector database as well as an ensemble of LLMs to help users answer their questions through VoiceBox. We use an ensemble of LLMs partly because when you're building, say, a query, we have multiple tasks to be done in terms of how to fine-tune and what it means to have an accurate query. We need that query to not be malformed. We need it to be accurate against the data model that you have. And these are all different jobs to be done, and that's why we have multiple LLMs supporting VoiceBox. From a user's perspective, when they ask a question to VoiceBox, all of that prep work of creating the embedding model and the vector database and fine-tuning an LLM, that's all done for them. So their question is then parsed with context from their knowledge graph to the vector database, and then sent to the LLM to produce a query that is then run against their knowledge graph, and then sent through another LLM to summarize those results, again, in a conversational way to be responded back to the user. Again, I want to highlight here some of the difference between a lot of the LLM tools that we've used and generative AI tools that we've used is that a lot of those tools are creating your answers in addition to responding to your questions. And so with VoiceBox, we're really generating a well-formed query. And so your response is going to be as accurate as your knowledge graph's data, not as accurate as the predictive nature of the LLM. And so one thing to note there is that you do need your data within a knowledge graph to be able to use this combined power of an LLM being backed by a knowledge graph. One way Stardog facilitates this is by having a knowledge catalog that can connect to your data catalogs if you have those internally, but also just read metadata from other, say, JDBC sources to help facilitate you finding data to bring into the knowledge graph. And then, of course, VoiceBox, as well as other automation, can help you build the knowledge graph around that metadata and insights. So with that, we'll switch to a demo here and go through a few videos of VoiceBox in action. So here's an example of VoiceBox being used in our Stardog Studio tool, which is an IDE for querying and managing your Stardog Enterprise Knowledge Graph. And in this query, I'm going to ask a few questions. First, I'm just going to ask a really broad question of what are the data sources that are in my system. And you can see being streamed there behind is actually a query that is being written. I didn't need to know any Sparkle to write this. And then I'm following this up with a specific table that I'm interested in and understanding the columns from that. So understanding the metadata that exists within that knowledge catalog. And you'll see that this is a little bit more of a complex query being streamed behind here. And again, that is providing the evidence that a user could validate or even modify if needed. Moving forward, we've also discussed that, Stardog VoiceBox is able to help you build your data model. And so this is Designer, which is our tool for helping you model and map your knowledge graph. And here I'm giving a fairly high-level overview of what a customer 360 model might include. I've asked for a few classes. It does take a minute or two here. And it's going to provide back a data model that I can review and validate or, again, modify as needed. And so this is just going to take a moment as it wraps up here. And then I'm going to be given a summarization of my model and the ability to review it. One thing really powerful about this that we'll see after is the ability for someone, once that model is presented, for them to tweak that model. So it's a combination of, here's a fair amount of automation that might get you 90% of the way to a data model, and then allow a human in the loop that really knows your business needs to modify that data model. So here I'm just reviewing the data model that was presented back. I could reopen up VoiceBox and continue my conversation, or again, I could use this GUI-based tool to continue modifying my model. Here I'll go back and actually ask for a modification or addition to that model. And then VoiceBox will return back that updated data model back to me. So again, that will just take a moment to run as we process that. And this is one area where you can see that you could work with VoiceBox for a long time, going back and forth on continuing to modify a model, whether that's adding more attributes or modifying some of those connections. So here we'll see that update of feedback being added to our order from customers. And again, this would be something that I could go ahead and accept that and carry on with my modeling and mapping journey. So here showing that from from that point of having my model, I could connect to various number of data sources and map so that my Stardog Enterprise Knowledge Graph would have map data to, say, a MySQL instance. So going back to our studio environment and asking questions of our knowledge graph, here I'm showing what VoiceBox can do with just a natural language question, the way that you would talk to a colleague or potentially build out a dashboard. You know, what were our total sales for Black Friday back in 2020? And it's able to give me a fairly succinct answer there. If I wanted something a little more complex, maybe I'm comparing 2 months, I can go ahead and ask for what were the total sales across December 2020 and 2021. So here, this is a fairly complex query that's written. We see we have multiple selects being joined in a group by. For some reason, you can see at the top there, VoiceBox loves to add distincts when maybe they're not needed. So, you know, it's not necessarily infallible or perfect, but still much faster than me writing this query myself or someone that maybe doesn't have that background in what's used for a graph query language. This is being shown in Sparkle. We also have an experience that is more global. So this is our cloud home environment where you would access Designer and Studio, as we were showing in some of the other tools. And here, based off of the context, sorry, the screen's cut off a little bit there. Based off of the context of your question, we're going to be able to identify the database that you're asking a question to, and I'm just going to ask the same questions that I was asking in Studio, and then return back a summarized response for the user. So something an end user without wanting to get into the specific graph query languages could use just for quick answers across their enterprise using the knowledge graph. So if this is something of interest to you, we are currently running an early access program. So if VoiceBox is something you would like to try out yourself or within your own organization, feel free to sign up for our early access program. This is launching later this month. And then we're also downstairs by center stage, just when you walk in to your left, if you have any questions for our team. And I'll still be up here if you guys have any questions and we have enough time. But thank you.
Oh yeah, I'm good. Oh, good. I'm good. Sorry to interrupt that awesome song. I grew up with that song. I love that song. But my name is TJ Sizemore, and I'd love to have y'all's attention just for a few minutes. I am the Director of Global Analytics at ASICS, the shoe company. And we believe in a sound mind and a sound body. So when I was looking at the agenda for this event over the past couple of days, I noticed a lot of content, a lot of information around AI, machine learning. But I want us to take some time here to not forget about the humans behind that, right? And that's you. That's all you right now, right? So that's going to be the focus of this conversation, whether you're leading a team, you're part of a team, or hell, you are the team, right? The role that you play and how these tools are built and how they're deployed, how they're actioned and how they're used, that's the part that I'm going to discuss here, and that's what I like to call the characters of data. So when I was in high school in theater, I really enjoyed this concept called characterization, where you would develop or create a character from what you were seeing on the page. A writer will give you clues as to what some context is within there, but as an actor, you kind of have your own creative spin that you can put on the character. So for me, I would add history, I would add backstories, because that would help me decide how my character would react in a given situation. So now you're probably thinking, TJ, I'm not here for an acting class, and I would respectfully say that, I think it's a good idea, because for me, everything that I learned in those 4 years of theater, I've applied to every job that I've had, especially within analytics. So when it came time for me to lead a team, to manage a team of data analysts and data scientists towards this concept of data literacy, right? Naturally, I wanted to pull from my background in theater, from my understanding of characterization. But this time, I became the writer in order to give my team the ability to bring their own creative spin to their character. So for today's discussion, I'm going to share with you my characters of data and how I manage my team towards their own character. But I want you to keep in mind that these characters that I created were a product of my own environment. So as the writer, as the creator, as the leader, you have the ability to create your own characters that may fit your world just a little bit better. So don't use this as fact. Use this as like a starting point or as a reference. So first, I just want to very high level say that our purpose at ASICS for the analytics team is just to influence decision making within the organization. Now, in order to do this, we needed to build the confidence of our stakeholders using our insights. In order to build this confidence, right, we needed to make the concept of data literacy a priority. The challenge that we faced was helping our team understand how they fit into this concept. So to help with this, I shared my characters of data with them. And by sharing these 4 characters, which you'll see here in a second, it opened up a discussion on how each individual person on the team related to one of these characters. So without further ado, I want to introduce my 4 characters to you. I went too far. So the characters are the steward, the scientist, the storyteller, and the strategist. Now, how they're set up, there are some clues to the behaviors that drive them. And I know that these animals, they might appear to be a little cartoonish because they are, in fact, cartoons. But I feel like classifying the steward as the crossing walk elephant, the scientist as the overreaching experimental giraffe, the storyteller as the calming and patient koala, the strategist as the wise and alert owl. Well, that helped me to set my own expectations against each one of these. So to me, this makes sense, right? But for the sake of exploration, we're going to take a look at each one just a little bit deeper and look at the traits that kind of defined them. So the steward is someone who is concerned with privacy. They govern the process. They advocate for quality. They are the eyes and the ears of the team. They are keenly aware and attentive to the needs of the organization. However, they cannot be afraid to say no or, not at this time. They are here to protect the data that our customers trust us with while standardizing the organization of our collected data, effectively making them the gatekeeper, but also the bridge builder. Now, they're usually organized, and they believe in the process of documentation a lot. It's a tedious and repetitive work, but it is important because it builds the foundation of our team that they work on. Without this focus, right, our KPIs would be inconsistent. Our source of truth, it would not be singular. And chaos would just wreak havoc on the team. I mean, maybe not that dramatic, but what would happen is people would be open to their own interpretations. And that's pretty much the same thing, I think. Now, the steward believes that they are here to advocate for our customers' right to privacy, even when the marketing team wants all of the email addresses. And this may push people into uncomfortable discussions. And unfortunately, the steward, the team, can end up being the brunt of blame for why the company is not progressing as fast as it should. And that is why leadership buy-in and support is absolutely crucial to the success of this team. Because if you think about it, right, there really can't be any accounting without the accountability. This is a scientist. This is someone who is curious, open-minded, they're unbiased with a little, healthy level of skepticism. They are the brains of process and automation. They can't be afraid to say, let's give it a shot, or we'll see what happens, right? The term fail fast applies directly to this person, because without failure, we all know there really can't be any progress. I like to think of them as the thinkers and the tinkers. They experiment to prove ideas or to create new ones. They are usually detailed focused with a whim of trial and error, heavy emphasis on the error part. And this level of experimentation is what drives the priorities of the company while creating a culture that thrives on questioning everything. They never rely on their gut to make the decisions, and they try to push people to think about why is it that you believe what you believe. This is a storyteller. This is someone who is enthusiastic, they're authentic, they're aware of their audience, they're confident, they are the voice of the data. They can't be afraid to stand up in front of people and tell them not what they want to hear, but what they need to hear. They usually get the credit for the work, right? Because they're the most front-facing to your stakeholder. But that's why it's important for them to remove the ego from their conversation and recognize that it's the entire team that's supporting that process. Now, don't get me wrong, right? Being confident is important to gain that trust with your stakeholder. But I would also argue that removing the ego is imperative to gain the trust of your team. They are usually creative in how they present insights, and they can be selective with what insights they communicate. But being able to understand the needs of the stakeholder is crucial to them telling their story. Lastly, this is the strategist. This is someone who is a leader, a mentor, they're a long-term thinker. They are the heartbeat of the team. They can't be afraid to look past the current needs of the team, right? Because otherwise they'll just get stuck trying to put out the fires that are in front of them. But they need to be able to identify the source of the fire to help prevent it from spreading. And they can do this, right? They can do this because they see the flow of data, they see the flow of insights, they see the flow of analytics, they see how it impacts the different parts of the organization. So that helps them to anticipate the needs and the necessities of the stakeholders and also of the team. They can identify the right people to put in the room, and they can also ask the right questions. They are sometimes described as cultured thought leaders, while at the same time cultivating thought leadership. So if you ask them a question, they may answer with a question, which is annoying, but it's in the hope of spreading or starting an open-ended conversation. Now, as I was going through these four, you probably had someone pop in your mind, someone you work with, someone you work for. You might even relate to one of these characters on the board, which I actually want to take a poll right now to see how many people do relate to this. So how many stewards do we feel like we have right now in the audience? A little bit? A couple? How many scientists do we feel we have? A little bit more? Okay, I mean, data science conference kind of makes sense. How many storytellers do we feel like we have? Okay, good. Any strategists in the room? Awesome. Okay, I saw some people double dipping there. That's okay. It's all right. That's actually part of the point, and we'll talk about that in a minute. But I gotta let my notes catch up. I am an elder millennial, so I have notes, and it is on my phone. So each one of these, they serve an important role in how you build this data-driven, data literate culture within your organization. Because much like a play, right, with its leading and supporting characters, it's important that each person, they know their lines, right? They rehearse their cues, they understand their role, because when it's time for the curtain to rise and the show to start, you have to trust in yourself and that those around you in order to make sure that the audience enjoys that performance. Now, I'm going to be a little bit vulnerable here because there is one thing that I fear the most within analytics, and maybe some of you might share this fear with me as well. But it is the fear that people just stop asking questions. Because when this happens, right, it could mean that stakeholders just don't understand the value that you bring. And that's when you begin to question the character that you're playing, the role that you are portraying. And imposter syndrome can set in. It can start to affect your mental health. I mean, there's still times that I struggle with it, coming up on this stage. I'm definitely doubting my credibility and hope that you all don't see me as an imposter. And I set that up because I do want to say that I have been slightly deceiving you all just a little bit, hopefully to get you interested in what I was talking about, because these characters, they're not really characters, right? They're more like characteristics. And it's the job of the manager to recognize where your team members fall within each one of these characteristics. So let me take a step back and revise something that I said earlier. Something I said I was going to share each character with you and how I manage my team towards their expectations. I'm actually going to share with you how I manage my team towards each one of these characteristics. Because, honestly, right, I am a storyteller, I am a scientist, I am a steward, I am a strategist. And identifying which one is my strongest trait to which one is my weakest trait, well, that's kind of the first step in the process. So this is who I am. I am someone who is curious. I'm a long-term thinker. I'm authentic. I'm an advocator. I can be the listener and the speaker, obviously. I'm not afraid to say no while finding new ways to support the needs of the organization today. I'm also always thinking in long-term ways, but I'm also finding new ways to create short-term needs solutions. I like to prioritize a safe working environment for people to fail and to learn from those failures so we can find new ways through experimentation. Now, I do feel a little awkward sharing this with you because usually it's not on a stage in front of people. It's on my own. It could be with my manager as we're talking through my person. And honestly, sometimes it just comes off when you're talking about yourself as you just being arrogant. But I think it's important for my own development. And this has been a great way to kind of organize and visualize my own professional development within my career with analytics. So let's talk about the visualization piece a little bit, because I really haven't shown you what I use to kind of document all of this. But I call this my performance critique. I truly believe that you can 100% be your biggest critic, your harshest critic, but you can also be your strongest supporter. And so by building this framework, I can not only monitor my performance, but I can also use it to determine which situation requires which characteristic, right? Do I need to be more of a steward here in this situation? Or do I need to be more of a storyteller for this situation? This is the history and the backstory that I create so that my character, so I know how my character will react in any given situation. So the first step, like I said, is to identify each level of the characteristic, and I tend to look at this as my authentic self, okay? So, and this is the score that I kind of gave for myself. I went high on storyteller, I went low on scientist, and I kind of went in the middle with steward and strategist. And now this past year, or year and a half, I've actually been focusing a lot on the strategist characteristic. How can I be more mindful of those qualities? And if you remember, the qualities are a leader, a mentor, a long-term thinker, the heartbeat of the team. I can't be afraid to look past the current needs of the team, otherwise they'll just get stuck looking at the fires that are in front of them. They need to be able to identify the source of the fire to prevent them from spreading. So these are the conversations that I discuss with my manager and set goals and milestones on how I want to improve this particular quality, this particular characteristic. So this is how I want to change my authentic self, which I know might be uncomfortable, but that's how I approach this. Because different moments can call for different qualities. So while I may rate myself low as a scientist, that doesn't mean that I never act like a scientist, right? Because there are moments where I have to increase that level a little bit and focus on how that characteristic is going to help drive us forward. And that can be difficult, and it can be hard to kind of understand how you need to switch that. So this is what I do for my own guidance, and what I've done for my team with their own development is I basically have them start with a blank performance critique. At the beginning of the year, I let them critique themselves, present their authentic self to me in this way, so we can look at the opportunities that they have to figure out what they need to change or what they need to improve upon. And by having these conversations with them, I encourage them to bring some self-awareness to the process. Maybe they want to bring in a different characteristic that I don't have here, that I haven't thought of. And that's part of the process too. Maybe they want to challenge themselves because they don't feel that they're as strong as a steward as they need to be, so they want to set that criteria for them. Now, for me as a manager, it's hard for me not to put them in a box, right? Like if you're a data scientist, you need to be high on the scientist. And that's extremely difficult to do because you need to give them the opportunity to tell you, hey, I'm a data scientist, but I'm not as strong as a scientist as I need to be. I have a business analyst who's really good at being a steward. They're not very good at being a storyteller. And you can argue that being a business analyst, you need to be a strong storyteller. But by letting him come to me and give me his authentic self, we're able to talk through, okay, here's the qualities and here's what we need to set for to help you build that strength as we go forward. So this is the focus of how we should build upon each individual on the team and not look at the job description to dictate that. So this helps me with the framing, focus your efforts, what you need to turn up, what you need to turn down in order to achieve a goal. It helps people understand in the context of company objectives because it gives them a clear connection to what they do and how that impacts the influence decision-making process within the organization. So I hope this was helpful, but I want to stress again that this is not fact to follow, right? You may need to add new characters to your story. You may need to focus on different behaviors to accomplish, or to create the vision that you've set. But as the writer, right, as the creator and as the leader, you have the ability to set these boundaries, but you must also provide a safe place for your team to bring their own creative spin to their own characters. Thank you. I do have a template. If you guys find me on LinkedIn there, I can send you a template to use for those discussions. But I appreciate your time and allowing me to talk through this crazy idea with y'all. Thank you.
Hello, everyone. These are some bright lights. So I vaguely see a haze. Anyway, my name is Cliff Karuba, and I am the chair of the Department of Quantitative Theory and Methods, as well as a faculty co-director for the new Center for AI Learning at Emory University. And what I want to talk to you today about is about preparing for the AI future in perhaps a different way a little bit than maybe some of the kinds of conversations you've seen earlier today and yesterday. And it's built around the idea of a new type of data science workforce, okay? And I'm going to wrap around to that at the end. I'm going to take a little bit of a detour where I need to kind of tell you what we're doing at Emory to give you a sense of what that new type of data science workforce can look like and why, and then kind of bring it around to the end back to what does that look like on a deliverable side. So first thing I want to do is ask a few rhetorical questions around did you know? And this is did you know about Emory, right? So first off, did you know what Emory's AI Humanity Initiative is? Okay, this is a new major initiative that has been going on for about the last 2.5 years, and it's really changing the face of Emory University. And what it specifically is a goal to be the world leader in applying AI and data science to solve the world's most pressing problems in health, business, law, and society, both in using AI as a tool to achieve those goals and in managing AI as a technology. Okay? So this isn't an initiative about the engineering of AI technology. It is about how it can be used to help us solve problems, taking advantage of the tremendous expertise we have in our School of Medicine, our Public Health Division, our law school, our business school, and the college. Okay? And so, second point, which I kind of alluded to, was did you know that Emory University has made a massive investment in AI through this AI Humanity Initiative? Over the last couple of years, we have hired 45 new faculty under this initiative, with many more planned. We have developed new AI and data science curricula, again with much more in the works that you'll probably be hearing more about in the spring. We have created the Center for AI Learning, which I'm a faculty co-director and co-founder of. And so I'm going to take a moment to show you a short video about this center. It's a way of synopsizing what it's doing, and then I'm going to move back to the broader picture. So ignore this next line. I'll come back to that. And in theory, something will happen any moment. There we go.
Artificial intelligence is going to change the way that we do everything that we do, but it's going to change it for the better if we do it the right way. We're all experiencing our AI moments right now. For us to use artificial intelligence in the most effective way as a society, everybody needs to be equipped with the skills to be able to know how to use it, and the skills to be able to advocate for themselves in this brave new world. And so what the center's doing is focusing on 3 different areas: faculty, students, and community engagement.
What's really exciting about our Center for AI Learning is that because we're interested in health, because we're interested in business, because we're interested in the liberal arts, we want to use the best tools there are ever in the service of those goals. And that's the beauty of this center.
For the longest of times, there were these 2 communities. There was biology and computer science that never talked to each other. And so people like me were always in the middle. You shouldn't be competing with AI, you should be using AI. And that is where I think we can contribute a lot.
By having this center, I think Emory really reinforces that no good work exists in a vacuum. What we can do with AI in terms of making processes and solutions better, faster, and cheaper will mean so much for so many people around the world, and I think Emory's education has only reinstilled that value.
This is really Emory taking a leadership position and trying to get out ahead of it. An immediate need or desire for us to partner with the center is to help educate the public, because it's an interest for us to grow the tech and entrepreneurship ecosystem more equitably and inclusively. And so if we can help them understand, hey, this is the way you could use it, and here are the applications, then that can make everyone in Atlanta feel like they're a part.
When I was coming to Emory, I did not really have a lot of knowledge about AI. Now, whenever I read about any business or I study about any case study in any business class, I always think through the lens of how can we leverage AI to deal with these in a real-world context.
This is an investment that's never been made before in the history of Emory University and the history of really any university generally.
The reason Emory is particularly well placed to invest in AI is because these domains we are really good at. Our AI.Humanity initiative, of which this center is a part, is deliberately positioned to take advantage of the domain expertise.
I think the future belongs to the students who need to actually understand what it is that AI is able to offer.
What we're really good at is integrating across all of the different disciplines, excellence in every discipline, medicine, health, public policy and law, business and free enterprise, all of these different areas. And what we're doing is being able to bring the technology to make each one of those areas even better.
Okay, so that's, I think, did a nice job synopsizing what I alluded to at the beginning. And so I want to go to one last did you know, which is that the department that I am founder of and current chair, QTM, the Department of Quantitative Theory and Methods, is one of the core elements of Emory's burgeoning strength in AI and data science. And so I want to transition a little bit now to what that vision is, how it's different than, why it's not called a data science department, how it's different than a data science department, what the philosophy behind what we're trying to do is, and how it complements existing major data science investments at great universities like Georgia Tech and others. Okay, so data science, right? When we think about the term data science, right, and what that skill set involves, I think generally people would agree it involves learning the math, the computer programming, and the statistical skills to be able to collect, analyze, and report results from data, okay? That can often thought about within a predictive modeling or a judgment AI type of sense, right? And there's no question investment in these skills is critical, right? This is transforming the workforce. This is changing how the academic setting does its job. It's transforming how we teach in the classroom. It's touching on everything. And so unequivocally, this is a critical move for society. At the same time, at QTM, we're looking to make a complementary, but we think equally critical investment, okay, to that kind of model. And this is the workforce we're training. This is what we think a major unfilled need is that we are scaling up and providing really at volume now to the region and beyond. So, what is that complementary investment? Well, I think the important thing to recognize is that these data science skills are the tools that allow us to answer questions and solve problems with data. But where do the questions come from? How do we know if we are collecting, analyzing, or reporting the right data? How do we communicate with impact what we learn from any particular model or analysis? Well, questions come from contextual fields of knowledge: natural sciences, social sciences, humanity, business, law, health, medicine, etc. Using data intelligently requires critical thinking and research design skills. And communicating with impact requires really investing in understanding how to communicate both orally and written, particularly from a non-technical or from a technical to a non-technical audience, right? A real investment in learning how to do that. How do you communicate the concepts and what's going on behind the scenes without all the technology that will make it hard for an audience to necessarily understand, okay? So where do these skills come from? Well, they are specifically the skills that are trained in domain expertise, whether you're talking about within the college, liberal arts setting, or the business school, or the law school, or health, public health, et cetera, okay? That's what the mission is. And so at QTM, we see the future workforce as one trained at the intersection of data science and these different disciplinary and topical domains, okay? So how do we think we should go about doing this? Well, first, let me say a little bit about the goal of the department, because this is going to inform the intellectual trajectory of the workforce we're training. Our goal is to have the world's preeminent, topically and methodologically interdisciplinary faculty unified by the principle of sound inference. So, if you look there, what you'll see is The word data science is not there, right? The word AI is not there. Does that mean that we don't value it or we're not training it? No. But it means that we see the training as necessarily needing to be broader than just a focus on machine learning, just a focus on neural networks or what have you, okay? And so we specifically, intentionally want to draw on a broad array of methods to help us get to the best answers or develop the best tools we can, given a full toolkit of what's available to us, not just focusing on one particular hammer or screwdriver or what have you. So, principles of sound inference, that means we're talking about drawing on mathematical modeling. This can be empirical mathematical modeling, can also be theoretical and analytic mathematical modeling. This is particularly important when you're talking about when the data generating process, the data you're working with, comes from something in which it was a strategic environment, right? So business is competing with each other. Causal inference. Many of the questions we want to ask are ultimately causal, not predictive. If I change this, will it cause that to be different, right? That's not a predictive question, right? Finally, predictive modeling and judgment, machine learning, AI, et cetera. Okay? So the idea is we want to train our students across these array of skills in order to learn which skills are most appropriate for the particular question they want to ask and the particular sets of data they have available to them to answer those questions. Okay? In terms of apply foci, we focus in business economics, health, ethics, governance, and society. Okay? All right. So, how are we working on training the student population? Well, we have a very particular pedagogical mission here, okay? And that is, we're not trying to just teach the students who are most gifted at math, who are interested in CS, who are interested in mathematics. We 100% want to train those people. They're an important and valuable resource for the future workforce, but we want to go beyond that. We think it's really important to go beyond that. And so our pedagogical goal is to teach Emory students the data science skills critical to using quantitative data to answer questions and solve problems in their applied field of interest, whatever their disciplinary interest and whatever their level of technical sophistication. If you look at breakdown of workforce demand, absolutely there's demand for data engineers, data scientists, et cetera. But that's not where the vast majority of these jobs actually are. They're in functional analysts, team managers, et cetera. Right? And so not everybody needs to be an A-level coder to make a major contribution or play an important role. And in fact, A-level coder is good for particular jobs, but maybe B-level coder is just fine, but you're really trained in understanding research design and how to think about interfacing and using that team's expertise to answer the questions you really need. Okay? So there's an array of jobs out there, and we want to train an array of students with an array of emphases so that we can cover that entire workforce space, not just a particular niche and then hope they can translate across. Okay. How are we going to do this? Well, the professionalization is a huge focus of ours. Okay? That means we need to provide students an understanding of where data science can take their careers. To understand, you can go into marketing with some data skills, and it can be incredibly valuable for you when you interface with the data teams. You can go in and be a data engineer. You can go into strategy. You can go into lots of different spaces, healthcare, whatever. We need to make sure that we're pipelining students across this array of demand, not just to one particular part of it. Second, we need to populate experiential learning opportunities that solve actual business problems. The difference between a work problem or a paper in a class and sitting down with some real data coming from UPS or coming from the Atlanta Regional Commission, coming from the City of Atlanta, coming from the DeKalb County DA's office, right? All have particular characteristics, particular challenges. Getting, assembling, cleaning, understanding, and then translating to the tools, those are all huge tasks that you really only learn how to manage when you're doing projects with real data in the real world. And so for us, it's critical that our students, when they graduate, are coming out with real applied experience, not just conceptual academic practice exercises. Finally, we are working on developing and supporting a lifelong community to retain talent and build a data science ecosystem in Atlanta, Georgia, and the Southeast. Specifically, we are working with our Pathways Center, a new center at Emory, in which we're creating an online affinity space where we will have students enter when they join the major. They do not leave when they graduate. I don't know how many of you have had this experience, but typically it's like you graduate, your email's shut down, and then you're directed to the alumni office if you want to stay in contact. That's not going to happen anymore in QTM. They're going to stay in that space and stay connected with Emory and the department moving onwards. And our external partners, which I'll say a little bit more about later, are also directly connected in that space. They have privileged access directly to our students from day one to be able to identify talent, recruit talent, train talent, etc. Okay? So this is meant to be a lifelong ecosystem that will be a source of a kind of a centrifugal force for Atlanta and the region. All right. How do we do this training? How do we put this into practice? Well, I'm going to say very little about this slide, but very quickly, which is we have an array of degrees meant to target different parts of the student body. So our main degree option is our quantitative sciences major and 2 joint majors built on the same model, in which students get the core training in data science, the computing, the math, the statistics, et cetera, and they take a track that they're going to apply it in. And this, we have over 20 tracks, including a very highly developed track in biology, neuroscience, across the social sciences, the humanities. We've got a joint major with the business school, so undergrad BBAs can come out with this degree. And the idea is that they're both learning the skills and learning the space in which they're wanting to apply those skills, and they're getting to integrate those 2 things at the same time as they get their undergrad degree. Then we have our applied math and statistics major that's joint with the math department. This is a degree that is for the most technically oriented students who really want to get into the nuts and bolts. They want to be the coders and the people who are deriving the models. We're there to prepare and support them. It's a very popular joint major. We have the QSS minor. Here, the important distinction is this is specifically an entirely different degree. It's not just a subset of our classes you take and you get to call it a minor. It's a different track of classes designed for students who are not mathematically inclined, but conceptually get it and want to develop the skills and understand how to implement the tools, again, at a conceptual level. Okay? So we are touching on many different parts of the space, and we're working actively on building out the graduate program now. Our master's degree just got running this year, and we're putting in the letter of intent for a PhD program, all built around this kind of philosophical model. So, just to give you a quick sense, here's our different tracks and electives. Idea is to give you a sense, we're serious about our technology training, right? Machine learning, causal inference, statistical theory, mathematical modeling, as well as some other important elements, and all the different tracks students can take. Okay, equally important to this is the professionalization side, right? And so we've got professionalization both through more traditional models, which are on the left-hand side. These are research labs, research fellowships, honors, opportunities for students to work with faculty, to really engage in the research process and hone their applied skills. Of course, internships with the different external partners, and on-campus hacks and events like DataFest, okay? The part on the right is the part I want to focus you on, which is really the novel part. So, learning how to really use these skills to answer questions and solve problems is hard. For those of you who may have gotten a PhD, you would remember the step from I've taken classes to, oh shit, now I've got to write a PhD. How do I do this? How do I identify a question? How do I, it's amorphous, right? So we're very intentionally developing elements to our program to help students along the path to being really effective at thinking through how to execute and apply these skills on real problems. So that starts with our data things. These are small modular co-curricular opportunities where students can come in as sophomores, even as freshmen, right? And it's just, hey, I'm starting to get exposed to this, and maybe I learn a little bit about data collection and cleaning. Maybe I learn a little bit about ideation around how to think about using data and what kind of questions the data set may be well suited for. And it evolves up each module one at a time, small units, until you get to, okay, now we got a question, how are we going to try to answer it? What are the tools to answer it? And then actually doing analysis and reporting, right? And so it's meant to be kind of a step-by-step process. It'll include everything from freshmen to seniors, where it gets our students early on to start understanding the steps of a research process and understanding the pitfalls along the way that can get people hung up. Then we have our capstones and our summer research practicums where students get to put that all together. So as juniors and seniors, they're doing semester-long or 6 to 8 week summer-long projects where they are getting a project from day one, and they're told by, they worked this summer, we had some people working with the Atlanta Regional Commission on affordable housing in the city of Atlanta, and their job was to get that data, answer the question, provide the results, convince the audience, okay? And so this is something we're crafting, we're investing a lot of resources in that go along with the classroom learning. Finally, QTM Prep to Pro is what I was telling you about. This is that online affinity space that we're developing that, that should be going live this year. And we're really, really excited about how this can create community and a really neat ecosystem moving forward. Okay, are students responding to this? I have a million slides on this. I'm going to give you just one. The answer is yes. So if you look at these numbers, this is the most recent snapshot. We started the major, I think, in like 2014. We now have a jump to 286 new declarations over the last calendar year. That is a 40% increase from the previous high. That's a huge jump. That number held out year after year translates to 1 in 5 Emory students will be touched by our curriculum. That's an enormous percentage. That puts us as large as biology and pre-med and those kind of spaces, right? So we're one of the largest student bodies on campus already, and we are continuing to grow. So there's a huge supply, and it's really broken out. There's a wide distribution. The minors growing, the majors are growing, QSS grew by 40%, et cetera. So there's a lot of students coming out of Emory being trained in this way. Okay, and this just gives you a quick overview of the kind of jobs a number of them have gotten. This is obviously a small snapshot, but as you can see, grad school, a lot of different impressive employers and positions secured. And I want to emphasize one thing, which is there's a lot of breadth in this. So people are going on to degrees in public health. People are going on to degrees in law. People are going on to degrees in business, right? It's not a niche program. All right. So this is a slightly more detailed slide about the Prep to Pro ecosystem that I've been talking about. I'm just going to highlight a few things and say the key aspect of this, the thing we've been very intentional about, is building a proposed program that ensures that every member of that community has a reason to be there. So nobody's doing this out of goodwill. There are real returns to investment from our external partners for participating in it. There are real returns of investment in our alumni, in our students, in our faculty, okay? And this ecosystem has been constructed with the support of our external advisory board and some members from that who helped us specifically design exactly what this will look like to ensure that there's going to be value add for everybody involved. So, just a quick snapshot. This is our board. We intentionally have a mixed board. We spread across people from younger people starting their degree options to very senior people like Lauren Weinberg. She's just moved to Annuitas. I don't have her new title, but she was Chief Marketing Officer at Square. Partners like Talitha Washington at the AUC Data Initiative, et cetera. So these are people who are meeting with me and supporting me, helping us develop and run the program, helping us make sure that what we're doing in the academic space is going to most effectively translate to the professional space. All right, so what's our value proposition from this new workforce that we're trying to train, this different way of approaching a data science education? The students in the next generation workforce, we believe, are ones who are going to be researchers and problem solvers, not just coders and technicians. Code writers who understand the spirit of the tasks they're trying to execute, right? So they're not just doing what's been told, but they understand why they're being told what they're being told and potentially can then provide feedback about feasibility in the process that can be understood and translated back and forth between the different parts of the project. Communicators who can really help facilitate communication between technical and non-technical audiences. Managers, ultimately, as they advance in the ranks, who are prepared to maximize the return on AI and DS investments. One of the things I hear a lot is there's a lot of companies that have invested a lot of people and a lot of time in it, and the ROI isn't clear, right? So this is intentionally designed to create the people who can help realize that ROI. And these are people who are going to be ready to learn no matter what stage of their career. That's part of what the ecosystem will achieve. There's going to be mentoring, there's going to be connections, there's going to be workshops in that space, there's going to be connections back to the cutting edge of research going on through QTM and our partners. And last, I just want to emphasize, this is unique. What we have done here at Emory, the resource available to you all here, is 100% unique. There is no academic program that matches QTM's scope, scale, or vision. There are lots of programs like, more technically oriented programs that are fantastic and are at a large scale, right? That's unquestionably true. But when you're talking about people in this interface that are really being trained on both sides of this equation, we have enormously more students than the next competitive program. I have a friend who has tried to develop one at Vanderbilt, it failed. I have another friend who developed one at Dartmouth. The last I heard, it had about 30 students. We're training hundreds of students a year. So this is a space, this is an opportunity for us to provide a type of workforce to complement what else is out there, to complement the skills that great places like Georgia Tech are developing, and to really make a difference in how business and the wider world benefit from this technology. So, if you are interested, if any of you happen to be someone who would be in a place where you might be interested in getting involved, getting connected, right? There are opportunities to join QTM and the AI Center for Learning. Okay? Doing so will gain you privileged access to shape and hire tomorrow's workforce. Okay? So obviously the access part I've already emphasized. The shape part I want to emphasize briefly. Specifically, our advisory board is involved in reviewing our curriculum, giving feedback, making sure that what we are doing in the classroom is best preparing the students for the jobs they need filled now and then tomorrow. So there's an active, ongoing reinvention with our external partners every year, okay? You can partner with us to solve critical industry problems alongside eminent data science and AI faculty in Emory. One thing I made a mention of, but I didn't emphasize strongly at that point, is we are looking on building out a research lab model where, for example, our faculty and professionals from partnering external partners or companies would work with our students on projects, and in the process get your projects, your kind of business critical projects answered, and also, again, it's training up those graduate students and those undergrads. It's getting them connected with your space. It's giving you privileged opportunities to recruit the best and brightest that you identify in that process. So we're working on building out that model, and that's something to, if anybody's interested in, Joe Sutherland in particular, the one who was on the video, is the first point of contact. We're inviting you to come in and participate in custom continuing executive education programs. So we've got a variety of types of programs built around how to train managers in this way of thinking, how to train data scientists in this way of thinking, right? 4 or 5 week, 1 hour workshops, that kind of build. And we can work with you on developing it to your specifications, what you need, which particular audiences you're looking to connect with. We've had conversations with Accenture about doing this. And we are really excited to step in this space and use that as another point of leverage, another way of us getting out what we think is a critical mission for the future of investment in AI and data science. You can engage with a responsible AI policy creation team. We've got a number of people invested in AI policy and AI ethics, and they're just super talented people that can help you in thinking about how to do responsible AI. And finally, you can become a member of our AI humanity community through the following things. We participate in executive breakfast series, member meetings, briefings on AI innovations and policy developments, annual presentations, and recognition at public events. So we are very actively especially for a college, this is very unusual, looking to really build an intimate relationship with external partners in a way that just isn't generally seen, okay? And so we're excited to be rolling this out, and we're excited about our students, and that is it for me. So I'd open if there's any questions. Thank you very much for your time. All right. If not, I will walk and I'll probably go and get a Coke or something if anybody wants to come on the side.
Okay, I'm good. I can start? Okay. Good afternoon, everyone. My name is Melissa Ngamini, and today I'm going to be giving you an introduction to topic modeling, so it's kind of a more educational talk. So my presentation, very straightforward. I'm going to give you a background of myself. Then we're going to start with what is NLP, what is topic modeling, and then what is the difference between topic modeling and topic classification, and hopefully in time for question and answers. So here is my picture in Senegal, actually. So I have a pretty strong mathematical background. I got my PhD from NC State in Raleigh, North Carolina, and I went to get my bachelor's at the historically black college and university in Baltimore, Maryland, which is Morgan State University. And I actually started in the education side. I was a math professor here in Atlanta at Morehouse College, a part of the AUC. And I'm currently work as the lead data scientist at ADP. I'm also volunteering in my spare time for Athletics. It's an organization that is based in Atlanta, and I'm the head of education, and in our program, what we are focused on doing is helping the most underrepresented group to gain economic independence through a data analytics bootcamp. But today, I'm not going to be talking about that. What is NLP, natural language processing? So when you're talking about natural language, the first thing that we have to understand is that natural language refers to basically the language used between two people to convey different ideas. Now, when you're talking about the data here, we are talking about text of books, we are talking about email, text messages, tweets. We are talking about transcript. Those transcripts could come from conversation that you're having on a phone call or conversation that you're having through a chat bot, a message bot. Now, the process in natural language processing is all about us transforming the words into a mathematical object that we can understand, and that object will be a vector. So now, what are the goals of NLP? So the first goal is really to give some kind of analysis, meaning that we are wanting to understand the topic, the sentiment, the writing style of the corpus that we have. Now, also, you have classification information you want to classify. So for instance, you will have a tweet, and you want to make sure that the information that is spreading is not misinformation. You want to classify your book by author or by theme. You also, at the end of the day, you have a conversation between two people, and you want to understand at what point is the person having a problem. So I want to be able to classify those different conversations and find the problem and not the problem. And lastly, of course, with Gen AI, we have generating text or product, right? So you have Reddit bot, you have website, customer chat bots, and you have a book generator. So now, when you go into topic modeling, right, I'm going to be talking about the different techniques. But before I do that, I want to kind of talk about what is topic modeling. So topic modeling is the process of learning and recognizing a collection of documents called topic, right? And then really, when you're talking about topic modeling, what you have to understand is that each document has a bunch of topics inside of it. And basically, those topics are just a bunch of words put together. So really, the goal here is to understand the latent variable. What exactly is the topic that shapes inside of all those documents or your corpus? Now, the first topic technique that I want to talk about is LDA. So this is latent Dirichlet allocation. So in this over here, what's going on is that it's a form of statistical topic modeling where we really want to be able to understand the topics, and what we have here is a latent variable. We want to understand the topic, document, the word topic, and things of that sort. Then you have latent semantic analysis. So in latent semantic analysis, what we are trying to understand here is that we understand that what we have here is really documents where you have this matrix that's going to help you understand the topic, document, and the word topic a relationship in a sense. And at the end, the one that I'm going to talk about is non-negative matrix factorization. Here, this is again another form of matrix factorization. Here, what you have is that you want to reduce the dimension, so you basically take your big matrix and you divide it into two different matrices, right? And in those matrices, basically, you're going to have positive values. So which means that with those positive values, you are very much able to understand very well what is the topic, what is the relationship in this document. You can make a very clear interpretation. So those are some of the techniques that I just wanted to mention here. And at the end here, I want to talk about the difference between topic modeling and topic classification, because people don't understand that topic modeling is what we call in data science an unsupervised learning problem, while topic classification is a supervised learning problem. So I'm going to go ahead and talk about first topic modeling by using example for different. So Warner Media, so here this is basically the problem. You have bots and you want to be able to understand the message that they are pushing. So if you think about it, I'm explaining it here because it's educational, because I want people to understand that when you are in the business world or in the corporate world, the way that you talk about your problem is very different. And so this is basically one of my first projects when I moved on from being a professor, which I miss so much. I miss students, so that's why I just want to teach still. So here, the first thing here is that you're going to have to talk about your business goal. So the business goal here is to determine, you have these topics here. You want to determine what exactly is a bot. So you want to create a statistical model where you're going to have a bot. And then after that, what we want to be able to understand is this network of bots. So we're going to have high probability bots and low probability bots. And we want to understand what messaging they are pushing. So of course, you have the client there, you have the data source is Twitter, and then we pull the data from 8 a.m. to 8 p.m. at night. And then so this is a problem that has the topic modeling, but it comes at a later time, right? So the first thing that we have to do is, first of all, understand the probability that you're bought, right? So that one we did with a gradient boosting model. Then you have the topic models. So we have a 5-topic model, and here I use LDA, which I mentioned before. So here it is. So here it is the topics, right? So LDA, you heard it. You know, topics are all about the Word and document or, you know, different things like that. So that's how we have it. So it's very quick. So here, basically, this is kind of like the network that we created. This is the impeachment network at this particular time of a point in time. And then here, you know, you cannot see it very well. It's kind of small, but you have those different kind of colors there with low probability bot, high probability bot, and you know, medium probability bot. And I just wanted to highlight a few people here. So basically, when you think of that, you think that they are actually bots. They are not. You know, they are actually regular people that because of the particular issue at this particular point of time, they were behaving like bots. That's why you see having a lot of relationships there. So for instance, you see that at that particular point of time, there was an ambassador that was giving a Senate speech. So the bots were talking about him. Then, of course, the senator who was leading the thing at the time was Adam Schiff. So you're seeing that. And of course, for most of the time, unfortunately at this time, Trump, for most of them, he was always behaving like a bot. But he's not a bot, he's a real person. So then now we're going to go into the classification problem. So the classification problem here, because the one problem before, I did not know anything, right? I just wanted to understand what the bots are talking about at that particular point of time. Here, I actually know what's going on. So here, what's going on is that we have a bot that's going to be talking to our customers when they come in. And we want to be able to quickly identify what they want to talk about, right? Because they call and they chat and they talk about, oh, my report, this and that. So we want to be able to quickly identify what it is. So the team has already actually labeled some of the past utterances for us. And now we want to be able to use those past utterances, train the model to be able to say, oh, whenever we see this word, we know they're talking about that. Whenever we see this sentence, we know this is what they want, right? So basically, the data here is past chatbot utterances. we're going to create a topic classifier. So this was a problem that we're trying to solve. So the first classifier that we use is a BERT, a transformer model. Then we also have a CNN, which is a convolutional neural network. And actually what was giving us the best result is actually a mixture of both of them. And I'm going to explain to you why. But this over here is a classification problem. It's not topic modeling. So this is what we have. So we have this model here that I call the BERT 80. That because it has 80 classes inside of it, right? So in this one, we had, because when the team was labeling things, they didn't finish labeling. So they had some classes called other and unclear. So in this BERT 80, you will never see this topic in there. So the BERT model is very good because it understands semantic, right? So basically for utterances that had a very close relationship between each other, the BERT model was able to understand those ones very well, right? But then, when you have the CNN 45, so here, 45 is because it only had 50 utterances BERT topic, a minimum. For the BERT, you could have even 2 utterances in it. It would be fine. But this one, in order for it to do well, you had to have at least 50 or more, right? So this model was very good because it's able to understand actually things that are very, very separate, meaning that they don't have any kind of correlation between each other. So the CNN will do very well for that. So at the end, what we did is actually we mixed both of them together, and we were able to get a better accuracy. So this is all I wanted to talk about. This is a topic that I really enjoy, really, because NLP, when I started in the data science world, I absolutely love telling stories. So when I said, oh, NLP, the word where I can have words, I was like, whoops, this is it. I don't want to do anything else, and I'm having fun working on those kind of projects. So if you have any questions, please let me know. And that's pretty much it. I hope I did not go over time, but thank you. Thank you. So do we have time for questions, or? Okay. Yes. The quality of the topic model, so this is an unsupervised learning technique, right? So basically, when you have the topic comes together, really, in order for us to make sure that they're doing well, we go through actually manually at the beginning. You go through manually to kind of see what are they talking about. Are they the same things in, the same sentences or same tweet that happen under the same topic, and you're thinking that it's doing well. But it's an unsupervised learning technique, so we are trying to create a topic model. We are trying to understand the data set, in a sense. So there is really no way of saying that this is good, because sometimes you will always have maybe a sentence that's not, or a tweet that's not related to the others that ends up in there, but because it's kind of like most of them are the same, we say, okay, this is good. Yes, you're able to choose. No, in order for you to choose that, there's a lot of different methods to be able to decide, if you're going to, the elbow method, if it's 5, if it's 10, and different things like that. So for us, because this was something that we needed to do very quickly for us to understand, we just decided on 5 because that was a number that we thought was good enough. Yes, but it could have been 10. We just decided 5 because of the business goal. Mm-hmm. Yes. I'm sorry? The convolutional neural net, in the second project, that's where we use a CNN. So that's basically, we build the model, inside of your Python script, I guess. And, you put your data in it. So what was happening is that, as I explained, right, when you are sending utterances and things of the sort, what happened is that you want to be able to understand the meaning. So a convolutional neural net will not have the same ability as a transformer model to understand the semantic understanding. So that's why we had to do the combination of both, because there are certain things like when somebody wants to do a tax update, a tax change, there are different topics, but the CNN will not be able to understand that very well. They will not be able to understand that these are totally different topics, while the BERT will be able to understand that. So. I mean, as I said at the beginning, when you are talking about natural language, you have to transform your word into vectors. So we actually transform all the words that we have into vectors. And of course, I'm sure with the many other talks that we have had during this conference, you heard about embeddings and things of the sort. Those are the different ways that we transform our words to put into our models. Yes. Yes, exactly. So for this particular one, that was 10,000 ones, because this was just related to a particular aspect of the chatbot. So we had 10,000 that was labeled manually before ends for the classifier. But for the topic modeling, of course, that was Twitter. That particular hashtag had about 3 million tweets in it. So yeah, so it depends, because the different hashtag at different points of time, they have different amount of things in it. So that one had 3 millions. Yeah. So that's why, 5 topic will be good enough for us to be able to understand quickly what the high probability bot and the low probability bot are talking about. Yeah. Okay, yes. Oh yeah, we removed that. Yeah, we removed that because actually when you are looking at bots actually have a lot of emoji and they add a lot of things. So, those are things that you have to remove from your data set. Yeah. So I think that's pretty much it for me today. So thank you so much for the questions and talk to you soon. Bye-bye.